हा झालं सर, युट्यूब वर लाईव्ह. ठीक आहे.
झालं ना सर?
हो
एक मिनिट, तुम्हाला पोस्ट करू का?
हो.
एक मिनिट थांबा, हे लाईव्ह होऊ द्या एक मिनिट. हा येस राईट सर.
हा झालं सर, युट्यूब वर लाईव्ह.
हा झालं ना सर? येस राईट सर. तुम्हाला पोस्ट करू का? येस
हो.
करा. थांबा, हे लाईव्ह होऊ द्या एक मिनिट.
सर ते युट्यूबचा आवाज तो
सर
तिथे
तुम्हाला
जवळ
पोस्ट करत आहे सर मी.
हो, तो इको होईल.
येस राईट सर.
सर सर
येस करा.
माझ्या नावाला नाही, NR पवारला पोस्ट करा.
आवाज कसा येतोय?
तर ते युट्यूबचा आवाज
हा सर तुम्हाला पोस्ट करत आहे सर मी.
हो.
युट्यूबचा आवाज कसं काय सर?
नाही, तो युट्यूब तुम्ही जर बाजूला सुरू ठेवलं ना, तर
हा
तुमच्या या मेन काय म्हणते
हा
झूम वर तो आवाज रिपीट होईल, तर तो थोडा दूर ठेवाल. आणि
ठेवून द्या,
युट्यूब
ठेवून
जे
द्या.
आहे ते
ठेवला सर, ठेवला.
1 मिनिट लेट चालतो.
हा सर, आता मी ऍडमिट करतोय ना.
1 मिनिट बस.
हम्म.
सर तुमच्या दुसऱ्या नावाला को होस्ट करा ना. डॉक्टर NR पवार म्हणून आहे ना,
हो हो हो.
त्यांना को होस्ट करा आधी.
येस राईट सर.
हा तुम्ही मला
झालं?
हा आता
हो.
झालं. आता एक काम करू आपण.
हो, आपण आपले
आता
गेस्ट ऍड करून घेऊ पहिले.
हा आता जे आपले गेस्ट आहे याच्यातनं ढोबले सरांना को होस्ट करायचं आहे का?
नाही, आपण ओमनवार सरांना करू, चिमनकर सरांना करू.
हा आधी करा, मग त्यांना को होस्ट करून घ्या, म्हणजे ते स्वतःला अनम्यूट तरी करू शकतील.
येस येस राईट सर.
नाही तर कोणीच अनम्यूट नाही करू शकणार.
राईट राईट राईट.
तुम्हालाच बनवायचं आहे को होस्ट आता.
हो सर, बिलकुल बिलकुल सर. ऍडमिट करून देतो सर यांना.
पवार सर,
बोला सर.
ते ऑटोमॅटिक ऍडमिट होऊन जातात काही वेळेनुसार नंतर.
ठीक आहे ना सर. नाही, आपल्याला माहिती आहे का, पहिले गेस्ट साठी हे ठेवावं लागेल. आपले ओमनवार सर जॉईन व्हायचे आहेत.
हा, तर त्यांना आधी जॉईन होऊ द्या, मग ते ऑटोमॅटिकली ऍडमिट होऊन जातील किंवा आपण.
येस येस राईट राईट राईट. आणि रघुवंशी सर, लाड सर व्हायचे पुन्हा जॉईन. हॅलो, गुड मॉर्निंग सर. हॅलो. हा, व्हेरी गुड मॉर्निंग सर. यू आर मोस्ट वेलकम सर इन रमन 2021 सर. हाउ आर यू सर? येस राईट सर.
सर प्लीज अनम्यूट युअरसेल्फ फ्रॉम युअर साइड.
हा
नाही ना सर, त्यांना सांगा अनम्यूट करायला. त्यांच्या साईड वरूनच ते अनम्यूट स्वतःला करू शकतील.
येस राईट सर, आपण करून देऊ इकडून.
सर
हा सर.
हे जे इंटरनॅशनल म्हणून एक
सर स्क्रीन शेअर करून द्या ना, ते आपलं मागचं
अच्छा ते
कॉन्फरन्स.
हा ते माझ्या या पीसी मध्ये नाही आहे.
हो का, पहा ना.
हा एक मिनिट, मी करतो लगेच, ते डाउनलोड करून घेतो.
येस राईट सर. रघुवंशी सर झाले जॉईन.
सर तुम्ही ते माझ्या मेलवर पाठवलं होतं का रमनचं?
हो ना सर, तुमच्या
त्या दिवशी?
व्हॉट्सअपवर आहे सर,
अच्छा
मेलवर पण पाठवलंय. वांड्रे सर, वांड्रे सर हॅलो. जेनेकर सर जॉईन झाले नाही का?
हॅलो,
हा सर, गुड मॉर्निंग सर.
गुड मॉर्निंग. गुड मॉर्निंग. बिजवे सर आले आहेत.
हो सर, हो सर, बिलकुल बिलकुल, थँक्यू सर. बस सर 5 मिनिटं 2 मिनिटात सुरू करायचं सर आपल्याला. लाड सरांची वाट पाहत आहे मी.
हो हो हो.
बिलकुल सर, बिलकुल सर.
माझं कीपॅड वर्क नाही करून एक ऑफिसला आहे, याचा पॅड काम.
Hello, good morning, everybody.
हा सर, गुड मॉर्निंग सर, गुड मॉर्निंग सर.
गुड मॉर्निंग.
गुड मॉर्निंग,
हा,
व्हेरी
गुड
गुड
मॉर्निंग सर. गुड मॉर्निंग.
याला गुड मॉर्निंग करा.
सर. गुड मॉर्निंग, गुड मॉर्निंग.
वागोळ सर, गुड मॉर्निंग.
या वा सर, बिलकुल सुरू करायचं सर आपल्याला. बिलकुल.
इन टाइम मध्ये आले वाघोळे.
आणि मॅडम करत आहे ना हे. हा. येस 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 येस, राईट राईट. ठीक आहे, ठीक आहे सर, बिलकुल बिलकुल ठीक आहे सर. बाय सर. सर सर 1 मिनिट फक्त, लाड सर जॉईन व्हायचे आहे, बाकी सर्व झालंय आपलं. ओके.
नामदेव,
बोला सर.
somebody from Russia, I
येस
think.
येस, राईट
He
सर,
joined.
राईट सर.
Yes.
त्यांना
Hello,
कोहोस्ट
sir.
बनवतो. 1 मिनिट सर, 1 मिनिट. सर माझा
Hello. Hello,
वाढवतो.
everybody.
Hello, how are you, sir?
I'm well, thank you very much.
How is the situation there, sir?
बरं. ठीक आहे सर. बस.
Everything is okay. How are you?
Everything is okay.
Okay.
Yeah, yeah.
Thank you.
बाळा आपला आवाज नाही येत म्हणते रे.
So welcome to this particular
ओमनवर
event.
सर, ओमनवर सर माझा आवाज येत आहे
Thank
का?
you. Thank you.
Yes, yes.
क्लिअर.
Clear, clear.
अच्छा ठीक आहे सर, थँक्यू सर. बाबा एक ही घे रे, डायरी घे, पेन घे माझा पेन.
रशियामध्ये तर रात्रच असेल अजून. सकाळ सकाळ. Yes, what is the time in Russia just now?
It's 1.5 hours earlier. It's just, well, that's
One.
not work.
So it will be very difficult for you to adjust
No,
with
no, no.
in IST.
That's okay.
Yeah.
Yesterday, I had a bath in the Volga River.
Okay.
You know, it's a cold, minus 12 degrees.
Right. Minus 12. Oh,
Yeah.
oh.
Well, and still I had a bath
Hello,
in the
Pawar
Volga
sir.
River.
Yeah.
हा सर.
सर तुमचं ते एक जेपीजी इमेज बेस पाठवता का मला माझ्या
बरं,
मेलवर
पाठवतो.
नाही.
हो.
I have been in India several years ago,
Yeah.
attending
What
the
time?
meeting in New Delhi.
When actually?
It's a couple years ago, probably, or maybe it's earlier, probably 7 years ago.
Okay. What institution you visited that time?
Oh, it was in New Delhi. I don't remember. It's
Okay.
New Delhi.
Once upon a time, Nikiforo has also come from that place. He visited Maharashtra, my university. He visited several universities that time. He's a nuclear specialist, Nikiforo.
Okay,
Yeah.
okay.
It was a time in 2005-06.
Oh, yeah. Okay. So, at present time, there are a number of programs, international programs between Russia and India.
Yes.
And there is a possibility to get a joint contract with the grant from the government.
Yeah, that is a very nice thing.
Yeah. Probably we will think about it.
So, very nice time with you. And you'll be
Okay.
here for 3 days with us.
Okay, thank you very much.
Yeah,
Thank
that
you.
will be very nice. And definitely by knowing field and specialization and the work, we can have somebody to collaborate with you.
हा सर.
Okay,
Yes.
सर
thank you.
गुलशन कुठे 30 वर पाठवत आहे ना.
एक मिनिट सर, तुम्हाला हे करू का सर? हा सर, लाड सर आले, तुम्हाला व्हॉट्सअपला पाठवलंय सर मी. हॅलो.
हा व्हॉट्सअपला पाठवलं का?
बिलकुल आता सुरू करून देऊ सर. हा.
ठीक
आणि
आहे.
माझ्या मेलला पण आहे सर, काही प्रॉब्लेम नाही सर. ठीक आहे. ओके सर. लाड सर जॉईन झाले.
Good morning, Raghuvanshi sir.
Good morning.
Hello, good morning.
Good morning, Omanar sir. Virtually आम्हाला चहा पाठवून द्या म्हणा. Virtually म्हटलं आम्हाला चहा पाठवून द्या.
हो बिलकुल बिलकुल. नामदेवनी तशी व्यवस्था करून दिली नाही तर चहाची.
बाजूला बसलाय तुमच्या.
Very good morning to all. And thank you for joining us at the 3-day International E-Conference on Recent Advances in Material Science and Nanotechnology, Raman 2021, organized by the Department of Physics, Art, Commerce and Science College, Maregaon, in association with the Department of Physics, Fulsing Naik Mahavidyalaya, Pusat. I, Dr. N.R. Pawar, convener of Raman 2021. On behalf of organizing committee, welcome to all in the International E-Conference, organized by the Department of Physics in association with the Department of Physics, PN College, Pusat. I am extremely privileged to welcome Dr. F.C. Raghuvanshi sir, Dean Faculty of Science and Technology. Thank you, sir, for giving us your precious time. I also honor to welcome Dr. O.P. Chimankar sir, Professor and Head Department of Physics, RTM Nagpur University, as the Chief Guest of this Raman 2021. We are honored to have Dr. Mahavir Singh sir, Senior Chief Scientist, CSIR National Physical Laboratory, New Delhi. It's a great pleasure to have Dr. Ajay Lad sir with us. It's our great privilege that with us a most eminent and the dynamic personality and the keynote speaker of today's conference, Dr. S.K. Omanwar sir, UGC BSR Fellow, Senior Professor, HGB Amravati University. We are happy to have with us our beloved principal, Dr. A.N. Gharte sir, Chairman of this Raman 2021. Who has constantly have been the pillar of strength and source of motivation for all the Alliance. It's our privilege to have our mentor, Honorable Principal Professor Dr. A.B. Patil, co-chairman of this Raman 2021. Organizing Secretary, my mentor, my guru, Dr. Professor P.T. Hamzade sir, co-convener, Professor P.D. Bageshwar sir, Dr. Bijwe sir, Dr. Bansod sir, Professor Gadpale ma'am, Professor Wandre sir, and all. It's my privilege to welcome all the eminencies who joins here. Once again, it's our privilege to welcome Professor Vladimir V. Petrov, Shandro State University, Russia. You are most welcome, sir, in this conference, sir.
Thank you very much. Thank you.
It's a great moment to have Dr. F.C. Raghuvanshi, sir, with us. I request to sir It's our great pleasure to have Dr. F.C. Raghuvanshi sir with us. I request to Dr. Binjve sir to present a memento as a token of love and appreciation to our inaugurator, Honorable Respected Dr. F.C. Raghuvanshi sir, on behalf of Raman 2021. Binjve sir. Bijwe sir. I call upon Dr. R.D. Chauhan sir, Registrar, College of Agriculture, Nagpur, to present a memento as a token of love and appreciation to our respected mentor, Guru Chief Guest of the Raman 2021, Dr. O.P. Chimankar sir. Thank you, sir. I call upon respected Lad Ma'am to present a memento as a token of love and appreciation to guest of honor, Professor Lad sir. Memento.
Thank you very much, Dr. Pawar sir.
Thank you, sir. Thank you, sir. You are most welcome, sir. It's our privilege. We have Dr. Mahavir Singh, sir. Sir is here in the meeting. Mahavir Singh, sir. Dr. Mahavir Singh, sir. Hello. Okay, sir. On behalf of the organizing committee, I welcome to Honorable Respected Mahavir Singh, sir. Thank you, sir. I welcome to our Honorable Principal, Dr. A.N. Ghade, sir, and Principal, Professor Dr. A.B. Patil, sir, virtually. It's a great pleasure to have Dr. F.C. Raghuvanshi, sir. I request you, sir, to inaugurate Raman 2021 and proceeding the abstract and all the published papers with along all the relevant documents of the Raman 2021. Also, I request you, sir, to kindly address the conference.
Thank you, Dr. Pawar sir, Chairman of today's inaugural function, Dr. A.N. Ghade sir, Principal, Art, Commerce and Science College, Maregaon, Co-Chairman, Dr. A.B. Patil, Principal, PN College, Pusat, Chief Guest, Dr. O.P. Chimankar, Professor and Head, Department of Physics, Rashtrasant Tukloj Maharaj, Nagpur University, Nagpur. Guest of Honor, Dr. Mahavir Singh, Chief Scientist, CSIR, NPL, New Delhi. Dr. A.B. Lal, Chairman, Board of Studies in Physics, Sant Gadge Baba, Amravati University, Amravati. Keynote speaker, Dr. S.K. Omanwar, UGC BSR Fellow, Sant Gadge Baba, Amravati University, Amravati. Convener of this event and hero of today's function, Dr. N.R. Pawar, organizing secretary, Dr. P.T. Hamzadeh, Dr. H.G. Doble, Professor, Department of Physics, Nagpur University, all the resource persons, delegates, and staff of the college. It's my great pleasure to be with you for the inaugural function of International Ink Conference on the recent advances in material science and nanotechnology, Raman 2021. Dear friend, in past we have organized conferences, seminar in offline mode. It is very difficult to organize offline conferences in small and remote places like Maregaon because we don't have sufficient funds, infrastructure. In addition to this, the guest, the resource persons, and delegates are not ready to come to such remote places. Fortunately and unfortunately, it may be fortunate, it may be unfortunate, there is a COVID-19 pandemic. This terminology, COVID positive, is not good. But in my opinion, it has given some positive sides. Due to this, we have adopted teaching, learning, and evaluation. And we are organizing conferences, seminar, and workshop in virtual mode. Dr. N.R. Pawar, the convener of this conference, is very talented, is very active. He has trapped this opportunity and organized 3 days International Ink Conference in Maregaon. I therefore congratulate Dr. Pawar and his team for organizing International E-Conference. Dr. Pawar has selected very good topic, that is recent advances in material science and technology. The material science play very important role in every field of human life. The different material has different properties, and as per our need, we can select the material. But sometimes we need a material of specific properties, and such material is not available. Then we have to change the property of the material. The property of the material can be changes by different ways. There are different techniques. For example, the combination of 2 or more materials by adding small amount of impurity to the host material. The properties of the material can be changed by using different synthesis technique. There are different synthesis technique. We have to select a proper technique to tailor the particular property of the material. By using proper technique such as the preparative parameters, we have to decide the preparative parameters, and by changing the preparative parameters, the material can be converted into nanomaterial. It is observed that the property of the bulk material is different than the nanomaterials. The concept of the nanomaterial is not new. In Ayurveda, we use the term bhasma. Bhasma has different property than the bulk material. Thus, we can develop the material as per our need. This material can be used in designing a smart devices. The device which can perform number of operations. Single device can perform the number of operations such as smartphone, which can perform number of operations. Dear friend, research play very important role in higher education. Higher education provide the basic to the research, whereas the output of the research to update the higher education. Thus, the research is an integral part of the higher education. These are two sides of the coin. Thus, we must consider research as one of the component of higher education. I know that today's generation is very smart, sharp, and fertile, provided they should get proper guidance, training, and environment. And as a senior researcher, as a senior faculty, and as the authority of the university, it is our responsibility to provide them proper guidance, proper environment, proper motivation to carry out the research. If we provide a proper environment, then they can give you a quality research output which is useful to the society and which fulfill the need of the society. Because we are carrying out the research, we publish the paper, but what is the use of this research for the society? Many times it is observed that the research output is not useful for the society, even it is not useful for academic purpose also. And the research which is not useful for society or for the academic fraternity, what is the use? Therefore, to get the proper output, research should be carried out in a proper manner. To start the research, the young researcher should identify their field of interest. Without knowing the interest, how you can start the research? He must identify the need of the society and the infrastructure facilities available to carry out the research. These are some of the important points to start the research. And on the basis of this, if you carry out your research by carried out a literature review on the basis of analysis of literature review, we can select a topic which can, on the basis of which we can start our research. And if you carried out your research in systematic way, then I am sure that your research will be a quality work. The research output must be published in a quality journal having high impact factor. In addition to the publication, we must able to file the patent and publish it. Only the publication of the patent is not sufficient. It should be converted into a awarded patent, and then the patent should be converted into a technology or product. And if we complete this process, that technology, that product will be useful to the society. The organizer, Dr. Pawar, has invited different resource persons working in different fields of the material science and nanotechnology. They will guide you, they will motivate you, they will give you a proper direction to carry out your research. You can share your thought, your innovative ideas with the resource persons and the delegates. I am confident that this conference will provide the solutions to the problem of the researchers. They will get new direction, new thought, new ideas, and this conference will boost their moral It will provide a motivation to carry out the research work. I therefore congratulate to Dr. N.R. Pawar, and I also thank to Dr. Pawar that he has organized 3 days international conference. I am sure that this conference will provide huge momentum, motivation to carry out a quality research work. I declare that the conference is inaugurated, and I also declare that the abstract, the journal publication is also published. I extend my best wishes for the grand success of this 3 days international conference, Raman 2020. I thank to organizer for giving me this opportunity to share my view. Thank you very much. Thank you. Thank you. Dr. Pawar, thank you.
Thank you, sir. On behalf of the inaugurator of this Raman 2021, I will share all the published paper, proceeding of the conference, abstract book, and the relevant document. Before that, it's our pleasure we have Honorable Dr. S.K. Omanwar, sir, with us. I request to Dr. Wagune, sir. Wagune, sir?
Oh, yes, sir.
Yes, right, sir. Please welcome to our honorable professor, our mentor guru, Omanwar sir, by giving a memento, a kind words of appreciations. Thank you, sir.
Thank you,
Thank you, sir. It's a token of appreciation, sir. Thank you, sir.
Thank you very much
Thank you, sir.
for giving me this particular honor, and offline
you.
also you have managed
Yes, thank you,
equal
sir.
to honor. Thank you
Thank
very
you.
much.
Thank you, sir. Now I request to our honorable principal, sir, to express his views regarding to this Raman 2021. Gharde, sir. Hello. Gharde, sir. Gharde, sir. Okay. It's a great pleasure we have Professor Dr. O.P. Chimankar, sir, here Department of Physics, RTM Nagpur University, Nagpur. I request you, sir, to kindly address the conference.
Thank you very much,
Thank you, sir.
and good morning to one and all present in the Raman 2021. I am very happy to know that Department of Physics, Arts, Commerce and Science College, Maregaon, in association with PN College, Usad, are organizing 3 days international e-conference on recent advances in material science and nanotechnology. That is a very unique name, Raman 2021. And I hope that such type of Raman 2021, the series of Raman 2021 or 2022 or 2023 will continue in the future. So this conference, Raman 2021, organizing during the 7 to 9 February 2021, the inaugurator of Raman 2021, respected Dr. F.C. Raghuvanshi sir, Dean Faculty of Science, SJB Amravati University, Amravati. Guest of honor, Dr. Mahavir Singh sir. Today's keynote speaker, respected Dr. Omanwar sir. Other guest of honor, Dr. A.B. Lad sir. Dr. A.N. Ghade, Principal of the Art, Commerce and Science College, Maregaon. Dr. A.B. Patil sir, Principal of PN College, Pusad. Dr. Hamzade sir, Organizing Secretary. Dr. Dhoble sir. Dr. Petro and eminent speakers and dear participants. The main objective of the conference to provide open discussion through e-platform under the pandemic situation of COVID-2019. The academicians, young scientists, researchers, technologists bringing together to meet the global demand of novel materials and big challenges in the field of material sciences and nanotechnology. I am very proud to give the remark about the conference 2021, and the major highlights of the conference are, the organizers are bringing out a souvenir and publication of research paper from well-known reputed journal in the big event Raman 2021. Organizers are inviting the applications for Outstanding Academic Excellence Award from young researchers, which would definitely motivate or ignite the young mind researchers. And it's a very nice and disciplined planning of the organization of the conference. The conference classified into one keynote address of Professor Dr. Omanwar sir, 4 plenary talks of Professor V. Petro, Russia, Dr. Tarek Bashir, Egypt, Dr. Abdul Hakim, China, Dr. Subhajit Shah, Taiwan, and 9 invited talks of eminent scientists and 164 oral presentation of the participants. And this indicates the big success of Raman 2021. I hope that the deliberations by the learned and eminent speakers are bound to bring well-meaning, thoughtful propositions which will be of long-term relevance to the society. The modern inventions in the advanced field of science and interdisciplinary nature of applications will be discussed in the conference. I assure that the deliberations will add to the knowledge of participants and also give them modern view to look at the field, and it would be applicable to betterment of society. For success of this conference, Dr. N.R. Pawar, convener of the conference, done very hard work and took pain. And the free hand given by the president of the society and the principal of the college to Pawar for organizing such big event is very impactful. Such type of cooperative atmosphere between society, teaching and non-teaching staff are not easily seen, which is very useful for the development of the college. So I would like to congratulate to President of the society, Principal of the college, and my beloved student, Dr. N.R. Pawar. I am very proud of you, Dr. Pawar, sir. I extend my best wishes for successful international e-conference Raman 2021. I wish the conference all success and participant of fruitful and productive interaction for multidimensional usages for the betterment of human community. Thanks to Dr. N.R. Pawar for giving me opportunity to talk before eminent researchers and felicitate me as a chief guest like a offline conference. So thanks to all.
Thank you, sir, for your kind words of appreciations. I request our below principal for his kind words regarding to the Raman 2021. Ghade, sir.
हाँ सर, येतो आवाज?
Yes, right, sir. Right, sir. Good morning, sir. Very good morning, sir.
गुड मॉर्निंग सर.
Good morning, sir.
Recent advance in material science and nanotechnology Raman 2021 मध्ये सहभागी सर्व मान्यवरांचे मनपूर्वक स्वागत. शेतकरी शिक्षण संस्था संचालित कला वाणिज्य विज्ञान महाविद्यालय मारेगाव जिल्हा यवतमाळ फुलसिंग नाईक महाविद्यालय पुसद द्वारा आयोजित होत असलेल्या इंटरनॅशनल ई कॉन्फरन्स मध्ये सहभागी असलेल्या सर्व मान्यवरांचे मनपूर्वक स्वागत व अभिनंदन. आमच्या संस्थेचे सन्माननीय अध्यक्ष जीवन पाटील कापसे, संस्थेचे सचिव सुधीर भाऊजी दामले, या आयोजनाच्या संदर्भात अत्यंत मेहनत घेतलेले माझे मित्र डॉक्टर एन.आर. पवार सर, को चेअरमन ए.बी. पाटील सर, सहसंयोजक पी.पी. हमजादे सर, संत गाडगे बाबा अमृत विद्यापीठाचे कुलगुरू डॉक्टर मुरलीधर चांदेकर सर, उपकुलगुरू डॉक्टर देगुरकर सर, संत गाडगे बाबा अमृत विद्यापीठाचे अधिष्ठाता डॉक्टर एफ.सी. रघुवंशी सर, आमचे पितृतुल्य मार्गदर्शक एफ.सी. रघुवंशी सर, डॉक्टर महावीर सिंग सर, डॉक्टर ओमनवार सर, डॉक्टर चिमनकर सर, डॉक्टर ढोबळे सर, डॉक्टर ए.बी. लाड सर, या सर्व मान्यवरांचं मी महाविद्यालयाच्या वतीनं मनपूर्वक स्वागत करतो, अभिनंदन करतो. आणि ह्या आयोजनाच्या संदर्भात अथक परिश्रम घेणारे पवार सरांच्या ह्या ई कॉन्फरन्सला आपण सर्वांनी सहकार्य केल्याबद्दल, आपण सहभागी झाल्याबद्दल आणि यशस्वी करण्याच्या संदर्भात आपण केलेल्या योगदानाबद्दल महाविद्यालयाच्या वतीनं आपलं मनपूर्वक स्वागत करतो, पुनश्च अभिवादन करतो, अभिनंदन करतो. नमस्कार, जय हिंद, जय महाराष्ट्र.
Thank you, sir.
Okay, sir.
Thank you, sir, for your kind words of appreciations. It's our great pleasure we have Dr. A.B. Lad, sir, with us. I request to sir kindly address to the conference. Dr. Lad, sir.
Thank you. Very good morning to N.R. Pawar sir. Good morning to one and all. Today, Department of Physics, Art, Commerce, Science College, Maregaon, in association with Department of Physics, PN College, Husat, organizing International E-Conference on Recent Advantage in Material Science and Nanotechnology is abbreviated as Raman 2021. In the presence of respected today's function inaugurator, Dr. F.C. Raghuvanshi sir, Dean, Faculty of Science Technology, Santa Gadge Baba Amravati University. My friend, Dr. O.P. Chimankar sir, Professor and Head, Department of Physics, Rashtra Santa Tukaji Maharaj, Nagpur University. As a chief guest, very special guest of honor, Dr. Mahavir Singh, Chief Scientist, CSIR, NPL New Delhi, and a very lovely known personality, respected Professor, eminent Professor, Dr. S.K. Omonar sir, ex-head, Department of Physics, Santa Gadge Baba University, Dr. my lovely friend also, Doble sir, all delegates, all participants, very good morning to all of you. Dr. Principal Ghade sir, Chairman of this function, Co-Chairman Dr. A.B. Patil sir, Organizing Secretary Mr. Hamzade sir, and very charming and lovely organizer, Manmidao, Dr. N.R. Pawar sir. Very good morning to all of you. Firstly, I am very thankful to the organizer, Dr. N.R. Pawar sir, convener of this conference, to give me opportunity for one of the part of the grand event of the conference as a guest of honor. The word Raman itself famous on the day 28th February as a National Science Day, and everyone know Nobel scientist Dr. C.V. Raman and its spectroscopy. Now, recent trend in material science and material industry range from solution for lightweighting, 3D printing, and surface morphology engineering, as well as in developing intelligent material and advanced composition within the enhanced characteristics like crystal growth, single harmonic crystal, double harmonic crystal, conducting polymer, thin film, glass ceramics, quantum dots, double perovskite ferrites material, nanomaterial. These are the most recent paid in the material science for the fabricating and developing the various device application like sensor, biosensors, batteries, defense need devices, farmer for the need of farmers. Now in the pandemic period, COVID-19, now everyone know the very importance of research in the field of medical science and industries. I know in 19th, the scientist Robert Freitas prepared a small tiny device named as for the species respirators on the basics of nanotechnology. And he has made the relation between the nanotechnology and health. In future, we will prepare for eating the nano foods. I think 7 today, 8 and 9 organizing, providing new dishes related for the food of good lectures, which is gives the information about the nanotechnology, nanosciences to the all the participants and delegates from the eminent resource person. So I congratulate to organizer organizing such lovely and great event. Again, best wishes to all, especially for the Dr. N.R. Pawar sir. Thank you very much, sir.
Thank you for your knowledgeable and the kind words of the appreciations. We are honored to have Dr. Mahavir Singh sir, Senior Chief Scientist, CSIR National Physical Laboratory, New Delhi. Sir, on behalf of the organizing committee, I welcome to you, sir. Mahavir Singh sir. Hello, sir. Mahavir Singh sir. Sir, you are co-host. You unmute yourself, sir. Mahavir Singh sir. Hello, Mahavir Singh sir. Now you are co-host, sir. Hello. Hello. Hello, Mahavir Singh sir. Now you are okay, sir. Very good morning, sir. Hello. Sir, आप हेलो
पवार सर ते जॉईन झाले नाहीत मला वाटते.
आहे सर, ते को होस्ट पण आहेत.
हो का?
हो.
त्यांचा ऑडिओ प्रॉब्लेम असेल, त्यांचा ऑडिओ प्रॉब्लेम असू शकतो.
नो सर.
He is not visible on the screen.
Maybe a net problem with him.
Yeah.
Pawar sir, go ahead now.
Go ahead.
Mentor, my guru, Professor P.T. Hamzade sir, Head Department of Physics, PN College, Pusad, and the organizing secretary of this Raman 2021, Sir, it's great pleasure you have with us. Now, I request you, sir, to kindly express your views regarding to the Raman 2021, sir. Hamjade, sir.
Thank you, Dr. Kasif, for giving me the opportunity to international. The chairman of today's function, Dr. Garbe sir, co-chairman, Dr. A.B. Patil sir, the inaugurator, Dr. F.C. Raghuvanshi sir, the chief guest and keynote speaker, Dr. S.K. Omanwar sir, Dr. P. Chimankar sir, Dr. S.J. Dubey sir, and Dr. Ajay Nar sir, and all the dignitaries present on the dais. It is my privilege and pleasure to welcome you all on the outset of the inauguration of e-conference on recent advances in material science and nanotechnology. Dear friends, as you all rightly pointed out, Dr. Umar Pawar is constantly working hard to make this event a grand success. He is really a hard worker, and that is the reason why such a grand event could be organized by the college in the rural and the tribal area. As last time Dr. S.J. Dubey sir pointed out that we are going from the global to the local. So international event is organized at the local institutions. It is the nara given by Narendra Modi ji, and hence this event has its own importance. And Dr. Umar Pawar definitely has put the rural institution on the international dais, and his efforts in collaboration. We are also in the rural area is at a remote place, but nowadays we are having all technology at our disposal, and with the help of this technology we could organize the international event in the COVID-19 situation. To organize this event, Professor M.R. Pawar has taken a lot of pain, and he called the research papers throughout the nation, and about 150 research papers are submitted to the conference, and I thank all the researchers for giving the grand support for the organization of this conference. And I am sure the 3-day conference will bring out the very recent topics. It will put all the people in their presentation, in their talks, will provide or will gain the knowledge which will give a new direction to the research field in Amravati, Nagpur region. I am very much thankful to Dr. N.R. Pawar for giving me the opportunity to talk on the occasion of the inauguration. Thank you. Thank you very much, Dr. Pawar, sir.
Thank you, sir, for your kind words of appreciation. On behalf of the organizing committee, as a convener of this Raman 2021, I am extremely delighted to welcome you all in Raman 2021 once again. Raman 2021 has about 300 participants participating from number of states across the country and across the world, making this conference truly international. Raman 2021 is rich and varied with one keynote address by a most eminent professor, Dr. S.K. Omanwar sir, 4 plenary talk by foreigner eminent speakers, 9 invited talk, and about 164 research paper presentation, oral presentation, and splits between 2 parallel oral sessions. It is heartening to note that Raman 2021 has excellent response. We have more than 117 full-length paper of high standard. Evaluation of outstanding academic excellent award was 100% transparent by respected viewers of the reviewer committee, and I trust evaluation of best oral presentation award and the best research paper award by chairman of the technical sessions and the experts will be 100% neat and the transparent. Proceeding abstract book and all research paper will be published very soon and will be shared on the screen and also on our WhatsApp groups and on your email address. Raman 2021 is on 100% of its commitment. It's my own experience. All the participants in Raman 2021 had joined heartily on this e-platform. I wish the Raman 2021 will be an enjoyable, memorable, and productive for the participants. I believe all delegates will be benefited substantially from Raman 2021 by the presentations of the eminent experts and the speaker during the Raman. I am grateful to all the renowned speakers and delegates for their participants that makes this conference possible. I thanks our parent management, our respected principal, Dr. P.T. Hamjade sir, organizing secretary, and all my mentors, my guru, convener, co-convener, and all who have contributed in their own way to make this conference a success. Thank you. Wish you all a wonderful time. Now, I request to a most eminent speaker and a most dynamic professor in a world famous professor for a keynote address, and my guru, mentor, Professor S.K. Omanwar sir. Sir, please address to us and deliver your keynote address. Thank you, sir.
Thank you very much, Dr. N.R. Pawar. For the first time, I am spelling like this, Dr. N.R. Pawar. Actually, I used to address him as a Namdev. Yes. Dignitaries, all my colleagues, Dr. F.C. Raghuvanshi, Dr. Chimankar sir, Om Prakash used to phone me every bi-monthly. Very kind words he has used. Dr. Lad, Dr. Mahavir Singh, and especially special presence is Ramdir Petrov sir, and 2% scientist in applied physics 2020, Dr. S.J. Dhoble, my very good friend, and all my colleagues. Special thanks to Dr. N.R. Pawar and P.T. Hamzade. Basically, this conference is being hosted by the college managed by Shetkari Sanstha, the farmers issue which we are looking for. The good management, don't interfere in academics. That's how Dr. Namdev Pawar could manage to get the things as per the wish and the quality. And second organization is my parent institution, PN College Pusat, from where I have been born and brought up in academics. I reminded the contribution of Dr. P.D. Bade, Dr. K.K. Batra, Dr. Kitukle, all my teachers that time in PN College Pusat. I immediately accepted the invitation to deliver a keynote. My host institution, PN College, is organizing this, is a co-partner. And both are my students, convener and organizing secretary, who were the favorite students during their own PG studies, UG studies. I know both students, these two, convener and the organizing secretary, they are having very good practical hand. They used to do themselves many things in their laboratory, and that is what is needed today. The topic of the conference is rightly pointed out, because we consider that the physics is a mother of science, mathematics is a father of science, and all other branches of science are there just sons and daughters. Some fields like electronics, computer science, IT and other data science, particularly nowadays data science has received lot of importance. All these are grandsons and granddaughters of physics. Mother and mathematics is the father. Mathematics is the language of physics, and unless and until you know the mathematics well, you cannot go for understanding the nature, because physics has the motto, the main motto of physics is understanding of a nature. And if we understand nature properly, we design our experiments to protect the nature. Protection of nature is important today. And therefore, whatever research I have carried out in luminescent materials, I tried my level best to manage all design experiments which will lead to environment-friendly developments. And therefore, my keynote address will be role of nanophase luminescent materials for environment-friendly development. So, shall I share my screen now?
Sir, yes, you are co-host, sir.
So, is it visible?
Yes, right, sir. Okay, sir, proceed.
Yes, I am proceeding.
Yes,
One
right.
minute. I am proceeding. Just a minute. I will scrap something here. Role of nanophase luminescent materials for environment friendly development. That is what I'm expecting to talk today. I'm happy that many more people have joined this event, and continuously there are people who are waiting in the room. This talk is dedicated to my guru, late Professor Dr. B.T. Deshmukh, ex-head Department of Physics, Nagpur City, and ex-dean Faculty of Science, Nagpur City. We learn mainly two things from him: how to work always for the betterment of the society and the nation building. Dr. Raghuvanshi, in his inaugural address, expected that the research planning should be for the betterment of the society. Those are the main important things which we learned from B.T. Deshmukh. He was a coordinator and convener of National Social Service Scheme. For 11 years, he had not taken a single pie, and from its monitor, whatever honorarium he used to get, he donated Matador, a vehicle, to university for betterment of the work related to NSS. Therefore, in our planning, Dr. Dhoble will be agree with this, that whatever group led by Dr. B.T. Deshmukh and whatever branches that are being created, all people are working for the betterment of the society and building a nation. We have many such people who are really working for the society. As said by Dr. Pawar, Raman 21, there were oral presentation about 159. Out of state presentations are 13, and out of Vidarbha, from the Maharashtra, there are 16 such presentations. Whatever list schedule which is being provided by Dr. Namdev Pawar, I made a statistics here, and from Vidarbha, there are 130 oral presentation. That is a big number. I congratulate all Vidarbha teachers and researchers to contribute a great things for this particular conference. So there is overwhelming response from the Vidarbha. And in Vidarbha, we know many people who are working for the betterment of the society. Just I have listed Dr. Dhoble, delivered products. Dr. Sangeeta Wankhede has also got a patent for the LICA LF6. The first for which my student, Dr. G. Agarate, has worked down on this. That is a very good first for which has been patented by Dr. Sangeeta Wankhede from KDK. The another Vidarbha Institute of Science and Humanities, my place, Amravati, Dr. Sangawar Madam, she is also doing very great work. Recently, the patent is being awarded, and biodegradable plastics he is working. The one more colleague from my own department, Dr. Wagole, he has been also granted the patent. User-friendly, cost-effective technology and products that are being delivered. In my presentation, I will present some results which are already transferred to Baba Atomic Research Center. The technology is being transferred through their projects. Some of the phosphors which we have prepared, this is also in line with the patent, and some are being qualified for processing. I will be presenting those results. Look at our regional resources and expectations. Vidarbha, since I am concentrating 130 presentations from Vidarbha, therefore I will concentrate on Vidarbha. Vidarbha is at the center of our country. Rich in forest. Mostly the population is rural. Urbanized area is very, very small. So far as people in this particular region are concerned, the people are hardworking. We witness in Vidarbha, Nagpur, all complete Vidarbha, we witness a lot of sun. So solar power is to be used optimally in this particular region. And we have got a lot of time because the land here is very good. We should look towards what kind of environment which we are having. The budget, what is being provided, union budget was declared just 3 days, 4 days last week. Resources we are having and the facilities that are available in various destinations. There are many laboratories now in Vidarbha, they are being approved for carrying out research. Laboratories are being getting recognized. Lot of facilities are being created by the people. All these facilities are to be shared optimally. And all the facility owners should give access to everybody for betterment of the society and the nation building. That is what the expectation is. Human resource I talked about, very good quality work is being carried out by the people belonging to our region. There are examples in front of us, I listed the names also. What we need is encouragement. Student will need encouragement to carry out the work which is being expected by the authority, what authorities that are being expecting. Dr. A.B. Ladd and Dr. F.C. Raghuvanshi has explained those things. We should take interest. We should have optimal leadership and the simplicity for getting whatever ideas that will be coined during this particular conference, 3 days deliberations. All those ideas are to be simply chalked out. I request Dr. Nandev Pawar to come with the recommendations of this particular Raman 21 conference. This is very important because Dr. Ladd has on WhatsApp, I have seen his message that Raman 21, Raman 22, Raman 23 will be continued. And this is the first year, therefore, expect the organizers of this conference, Dr. Namdev Pawar and my own parent institute, Dr. Hamzade, Dr. Narendra Khaire is there. I am very much happy that all people from Pusad are also witnessing this particular event. So we should come with some recommendations. Look at the budget. I am just looking for the higher education budget and that to the research and science and development. You see, PM Research Fellowships, 2020-21, there were only 75.89 crores. This amount has been doubled this year, so that the research fellowships which are being awarded to the innovative ideas and the meritorious students from PM Research Fellowships, like whatever fellowships are being awarded this year, there will be 2 times. So there is a larger scope for motivation because the budget provision for PM Research Fellowship is being enhanced. Last 10 months, we are witnessing the education through ICT, what kind of education is being carried out, what kind of examinations have been conducted, and what kind of results are being declared. there is a very large difficulty for admitting students to postgraduate studies because everybody got 96, 97, 98% at BSc. The education through ICT, we have to optimize it. The budget for this is also being increased from 48 crores to 150 crores. Setting up of virtual classrooms and massive open online courses, MOOCs. The budget is also 3 times. Digital library, National Digital Library, the budget is increased to again 2.5 times. PME Vidya, there was no provision earlier. Now 50 crores have been sanctioned. Academic Bank of Credits, 5 crores were there, now 50 crores. And National Institute for Design Innovation, there were only 16 crores. Now this amount is also getting doubled. See the thrust and the vision, the wish of the central government, the country. Country is looking for good ideas, innovative ideas, productive things, productive research, and having more and more startups. And so that our country will become the Atmanirbhar. Program for apprenticeship training. This 3 times, see the budget. A new Asian fellowship, that is also 2.5 times. And RUSA used to fund now, earlier only 166 crores during last year. This year, 3,000 crores. See what kind of development we are expecting centrally. Therefore, it becomes more responsibility of particularly the teachers and the researchers to concentrate more on innovative ideas, productive research. Talking of the environment friendly, what is environment? Environment is a French word, which is called as surrounding. Environ means surroundings. Hence, everything surrounding us is the environment. Environmental Protection Act has come in 1986. The new education policy, NEP, which was also established September 1986. See the coincidence. The Environment Act and the new education. After 34 years, the NEP, National Education Policy, new education policy is converted into National Education Policy now, which is after 34 years, the National Education Policy is being revised. So this is just a coincidence. Environment as the sum total of what is water, air, and land. Whatever research which is being carried out in water, air, and land and benefits on this particular 3 factors, that is very much important. So we have to concentrate on environment by giving new product or suggesting new proposals among themselves and with the human beings, other living beings, and the property. It is a comprehensive sum of all living and non-living things and their interactions. It is an applied science. Environment science is an applied science as it seeks practical answers to making human civilization sustainable. Sustainable means what? Shashwat. Development is vikas. Sustainable development is a shashwat vikas. You are assured regarding the conservation and protection of the environment. So human civilization sustainable on the earth's finite resources. Its components include biology, chemistry, physics, engineering, sociology, health, anthropology, economics, statistics, computers, and philosophy. So many components are there. Actually, it has got the multidisciplinary nature. Therefore, every person doing research in pure sciences or applied sciences or anything in social sciences, humanities, they should consider the environmental science and protection and conservation of the environment first. That should be the topmost priority. Environment consists of these four elements: atmosphere, hydrosphere, lithosphere, and biosphere. This comprises everything, whatever we are looking for. What are the physical elements? Space, landforms, water bodies, minerals. Biological elements, plants, animals, microorganisms, and men. We have seen microorganism corona effect during last 10 months. So much of quality research we are carrying out, but Indians have shown that within the 9 months, 2 vaccines have come. That is a great achievement. And that may be the reason because this current budget 21-22 has included establishment of 4 biological institutes simultaneously in our country. This is a great achievement. Cultural elements are economic, social, and political elements that are essentially man-made features for the elements of the environment. Why I should know environment? That was in 1971, UNESCO cleared that the awareness about the environmental problems and people among the people, imparting basic knowledge about the environment and its allied problems, developing an attitude of concern for the environment, motivating people to participate in environment protection and environment improvement, and acquiring skills to help the concerned individuals in identifying and solving environmental problems and striving to attain harmony with nature. That was in 1976. But what is today? Today's importance of environment studies are as follows. To clarify modern environmental concept like how to conserve biodiversity. So whatever research which is being carried out, it has to address to conservation of biodiversity. To know the more sustainable way of living. So how the progress can be sustainable, development can be sustainable. To use natural resources more efficiently. I know that the ash problem is there near the college of Dr. N.R. Pawar. Lot of ash. He has set up the nanotechnology there, nano laboratory, which is leading to getting a useful, more effective product from this ash, air ash. To know the behavior of organisms under natural conditions. To know the interrelationship between organisms in population and communities. This is very much important today because of the pandemic which we have witnessed during last 10 months. Interrelationship between organisms in populations and communities. To aware and educate people regarding environmental problems at local, national, and international levels. So this is what is important for having consideration of the environment for planning and designing the innovative, productive research. What kind of pollutions are there? Pollution air pollution, water pollution, noise pollution, spilling of oils in ocean littering, soil contamination by lead, heavy metals like mercury, arsenic, and PB. They are very dangerous. Soil contamination and water contamination. The human life is becoming more and more hazardous because of these contamination. Important is radioactive contamination, thermal pollution, visual pollution. I think pollution in the field of education is also becoming more important. Therefore, maintenance of the quality and the standards, transparency in administration, actually educational administration, is very much becoming important. And that is a good point that Dr. N.R. Pawar has illustrated those things, transparency and how this is being managed, how papers are being screened, reviewed for this particular conference. That is a good point which is to be noted here. A broader view of pollution and so on. Natural resources depletion. We are witnessing natural resources which are getting depleted, all these natural resources from solar energy to atmosphere. See what kind of depletion is there. Actually, the deforestation, cutting of the trees, the environment is more and more suffered from the deforestation. And whatever deforestation which is being witnessed in India presently, these are the reports of 2020. 33% of deforestation is carried out for the electricity generation. I have said our resource is what? Our resource is sun. Lot of sun is there in the Vidarbha. Why not to go for solar power utilization? Design technology, design materials which will improve the efficiency of the solar cells. Presently, we have crossed the limit. Different kind of solar cells are being used for electricity generation, improve the efficiency of the existing establishment of the solar cell. There we are working. 27% of transportation, environment, deforestation. The deforestation, 27% of deforestation for the transportation. Allowing vehicle to go quickly, improving the speed, getting more and more roads, Samruddhi Marg and all these transportation. 27% of deforestation which we are witnessing now. Industrial, for industrial purpose, 20%. And 13% is for residential because the population is growing on and more land is required for building houses. Percent deforestation is for agriculture. So I have shown that in green. If 7% deforestation is there for agriculture, but it is only for the forestation, one can consider. My proposition for today's talk: environment friendly sustainable development and what is the role of luminescent materials. Cost effective methods for materials we are concentrating on, and we are giving more emphasis on precise performance rather than the high sensitivity. People are going for the sensitive, more sensitive product, but precise performance is very much important rather than giving high sensitivity and high accuracy. Using resources optimally, looking at the SD is the sustainable limit. I am very much thankful to my whole team of workers, students, research scholars, who are the part and parcel of this particular conference event. They have worked very hard since beginning. Nitin Ingle, Dr. Bhatkar, Dr. D.S. Thackeray, and all these very recently, the people who are working presently, 30 names are there. All these people, Dr. Sonekar, Agate, Pankaj Belsare, Pankaj Nagpur, all these people are working. For what? We design the cost-effective methods for synthesis of the materials. And why materials are important? Materials plays very important role in the whole development of the world. Look at our only the materials. Whatever you see from your eyes, these are nothing but the materials. Materials are nothing but the composition of molecules. Molecules are nothing but the composition of the atoms and so on and so forth. So material science becomes a very important thing because it serves the comfort of the people living on this planet, a beautiful planet, the only planet on which living organisms like human are also present. We do not have any other planet where human is available. At least we are not knowing it. Therefore, it is very important to protect the environment and protect the life on this land of ours. What is the sustainable development? The sustainable development recognizes the growth must be both inclusive and environmentally sound to reduce poverty and build shared prosperity for today's population. Whatever population we are having, and it is continuously growing, we should look at to what kind of the population the number is there, and we should design accordingly. And to continue to meet the needs of future generations. That is very important. It must be efficient with resources, whatever resources which we are having, and carefully plan to deliver immediate and long-term benefits for people, planet, and the prosperity. That is what the sustainable development I mean. It includes environment-friendly development. The SD implications are environmentally sound growth, inclusive growth, need of future generation, resource, efficiency, long-term benefits, and shared prosperity. These are the implications of the sustainable development. We have gone from the agriculture society to the knowledge society on x-axis positively. That is what we are witnessing, social transformation. But this knowledge society should, through innovations and innovative ideas, should get converted into knowledge products to the information products. And whenever we got information through building networks, active networks, we can convert it into industrial products. And through technology, we can have a raw material agri products. And that agri products should be the organic agriculture, which is hygienic. So the economic growth is not the only objective. While looking at the economic growth, a social transformation is also to be witnessed. And that is being expected in the sustainable development. We propose a center, and I will not go in detail with the center because this particular center is being shortlisted by the central government, and we are expecting that 84 crores of grants will be made available to Sant Gadge Baba Amravati University under the leadership of Dr. Muralidhar Chandekar sir. I was the chairman of this particular committee, and I submitted this particular proposal by taking the advices of about 39 scientists. Coming to my own field, luminescence. Luminescence is defined as the emission of light by bodies which is in excess. Light emitted by the bodies which is in excess of that attributable to black body radiation. So apart from the black body radiation, whatever light which is coming, which is in excess and persist, means it will persist considerably longer than the periods of optical radiation after the excitation stops. So excitation is very much necessary. And emission is for longer time than the optical radiations. So each word which is written in red and blue, that is very much important for understanding the phenomena of luminescence. And the materials which are exhibiting these particular properties are called as the phosphorus luminescent materials. The principal excitation and emission. outside energy is being absorbed by the activators, and then spontaneously there is a emission. Or excitation energy in B part absorbed by the sensitizers and then transferred to the activators, and then you can have the emission. There is a mechanism as well. The configurational coordinate diagram is known to everybody, and all these people are physics people. They know how the transitions are being made from ground state to the excited state and non-radiation, non-radiative emission, and then emission between E1 and E0. What is the difference between that? Excited to excited, again it will go to the ground state. So absorption of external energy is very much necessary for excitation, and when at higher stage, the metastable stages, the electron small time, and then because of the energy gap, whatever energy which is there, by the giving emission transition, specific transitions, atomic transitions by the electrons, that energy will be coming out the mechanism. The luminescent materials are having applications in diverse field. Actually, luminescent materials, the field of luminescence is multidisciplinary. It has applications in almost all walks of life. Not only medical sciences, but all electronics, what gadgets, display devices, lighting devices, X-ray, CT scan, TLD, radiation monitoring, then scintillators, then what new? LCDs, LEDs, TV screens, CR tubes, and all full color EL lamps, white level. Dr. Doble will be giving more on display devices. He has worked on all those field. He is having the talk also. The composition, this is the simple periodic table, 112 elements, and what are the activators, what are the sensitizers, what are the dopants, and what will make the host materials that is being depicted. And most of the people are knowing this. Rare earth and transition metals are very much important for effecting a transitions in the given host. As I have said, the synthesis methods, the methods of synthesis, these should be concentrate more, because this should be, the method should be wet chemical method, not consuming much sophisticated instrument, what not requiring much sophisticated equipments. The method should such that this should give the product of desired morphology, desired particle size, and desired properties. If you are applying that material to somewhere, what is the requirement of this application? First, find out what size of particles are required, what performance is required, what energy is required, how that energy is to be provided for certain applications. From this, we have to find out that particular method for synthesis of the desired material, which will satisfy the requirement. So it is the reverse engineering as well. People are making some materials, studying the properties, and publishing the papers for designing or for applications. But this is from one side, where that material is being used, for what purpose the material is to be synthesized, the requirement of that material. If you want a TL or OSL material, what is the requirement? The material should be consisting of the Z effective value around 7.4, so that the batches which are put up on the pocket, when person goes inside the nuclear reactors and the installation of nuclear radiations, the exposure radiations which are being absorbed by the human body should be same as the radiations absorbed by that material. So human equivalence, tissue equivalence is 7.4. Therefore, the material should satisfy this particular condition first. Forget about the sensitivity. Sensitivity can be improved further. But while designing the material, we should look for what is the desired application. So these are the things. Therefore, I am concentrating more on what methods satisfies what properties. So the combustion synthesis, which is being started by K.C. Patil for aluminates, and we, our people, are the first. Dr. Bhatke, Dr. Thakre, Dr. Nitin Ingre, they are the first to implement it for silicate, vanidates, garnets, and other kind of materials. Even some fluorides can also be prepared, phosphates, and so on and so forth. So this is a flow chart. You can get the information from the literature. This is the best example that everybody knows, that the Y2O3 doped with EU3+, that is the very good, well-studied phosphor. What additional things we can do this? Now, this is the phosphor which is being used in many applications, many, almost all applications. It is for the red component, red emissions, EU3+. Now see here, what we did. The phosphor is made by 4 different methods. Solid state diffusion, combustion method B, C is aldoketo method, D is co-precipitation. And see here, A is the solid state diffusion method. See the particle size here. And here distribution. The A graph on right hand side column, the topmost, A, SSD. You will see that the particles, the dumbbell shaped graph, Gaussian distribution is being witnessed by solid state diffusion, and solid state diffusion is the most applied, widely used method for making ceramics, what kind of materials, inorganic materials, and always gives that is Gaussian distribution of particles. You have prior particles of mean size and the particles of smaller as well as larger size. The full width at half maximum plays very important role in making such particles. Second method is the combustion method. Combustion method, wide range. You have got big particles as well as the small particles. Aldoketo is better than that. And co-precipitation, the wet chemical method, is the best of all for Y2O3EU, making of Y2O3EU. Why? Because you see the last D graph here, very small width, narrow distribution of particle size. Almost all the particles are of same size. And their distribution is very, very small. And it is very easy to adopt. The desired particle size, which is of the order of micron, 500 nanometer particle size, 300 to 400. Most of the applications of Y2O3EU are in this particular range. Whether you go for display devices, whether you go for solid state devices, whether you go for CFL, and whatever application you are looking for. So this kind of study can be done by at any laboratory. Not big facilities are required. The people who have been recognized as a supervisor at their institutions, no big facilities are available. But with a small little bit of facilities that are available in chemistry lab, you can use those facilities and do good piece of work. This method of synthesis is very important because you want to look for the morphology, you want to look for the particle size, and you also look for the batch processing. When you go for scaling up the method, because large amount of products are to be synthesized, then one has to scale. And the method should be uniformly adopted for large amount as well. This is what is needed for sustainable development. There can be many more examples which I will be giving for 1,000 materials are being prepared methods by my students. Credit goes to all my students. They work very hard and they are giving beautiful products. See the granules and see the photographs. This can be done, and these people are working at their own destinations by making, because they have been trained for synthesis, and synthesis is very important. Most synthesis nobody does. Synthesis and innovation in the synthesis, people like us, the hard worker from the Vidarbha, these people are very much known for the synthesis. We have prepared so many products and having publications in reputed journals like Scopus and Thomson and Reuters. The numbers on each histogram is the number of publications in those reputed journals. For example, see lighting, the phosphors which are used for lighting purpose, 47 publications. Radiation, TL and OSL material, 42 publications, and so on and so forth. Or nano, or biomaterial, solar, UV, phototherapy, and display devices. These are what the luminescent materials that are being there. The example is the TL and OSL materials. And I think so I received a message that I have to sum up, but this is what is my research which is being starting here. Till whatever time I have consumed, it is for planning and designing. I will quickly go within 5 to 10 minutes. Can I have 10 minutes, sir? 10 minutes?
Okay, sir. Okay.
Yeah. I will sum up within 10 minutes. I will give only cursory remark. The TL and OSL materials, as I have said, the people are desired to work in the nuclear installations. The nuclear workers' personal monitoring for these sensitive materials are required, and presently all these materials are being imported like CA-Super-DY, Rentec technology for TL, and alpha L2O3C, that is what is OSL dosimeter, which is being widely used. Presently, these two materials are being imported. Lot of work is focused on obtaining the substitute for the same. There are many group, particularly group from Vidarbha is working, PRC group is working on making those devices. I'm very happy to inform you that we have given substitute for both CSO4DY, Rentec 3, and alpha L2O3C. The technology, it is being transferred to the bioatomic research. Tissue equivalence, the important requirements of this that are being mentioned here, I will just give. This is the early work which is being carried out in the AERB work. LICA-LF6. See, the LICA-LF6 EU is the material which is a replacement for the CSO4DY. See the sensitivity in the first graph, left-hand side, right-hand side, you see the sensitivity against CSO4DY for beta rays, for gamma rays. Energy response for X-rays, that is also being for different. Dose linearity is also being studied. It is all time better than CSO4DY. Dose linearity for beta rays and gamma rays is also being observed very linear. Dose linearity for X-rays, 6 MeV, 15 MeV, 8 MeV, 10 MeV, 12 MeV, various kinds of X-rays, we have seen and reported those things and delivered to BRC. Fading effect due to storage and batch repeatability is also being done. Pankaj Belsare and Agarade did a good piece of work on this material. The OSL sensitivity at that time, which is also being seen, but this particular phosphor LICA-LF6 is less sensitive than the OSL grade Al2O3C. It is just 5 times less. Therefore, we have to think of different material for OSL. The prominent OSL, as I have said, the replacement for OSL, which is found to be LMP, lithium magnesium phosphate, doped with a TB and doped with a boron for thermal stabilization. And the method which we have used for the first time, which is a modified solid state diffusion method, and method as well. By different method, but different materials are being studied, and they're published in the reputed journals. The name of the journal is also being given with their impact factors. Very reputed journals. There are 11 such publications on lithium, magnesium, or alkali halides and metals, phosphate. All these are phosphate and oxides materials are used for making. This is what is synthesis of luminescent power Tb3 plus LiMgPO4. That is a very good 4.3 times more than whatever Al2O3C phosphor is giving. That is very important. So more sensitive phosphors are being proposed and they are being prepared. There are so many publications which I have listed here, and these are the materials, the sensitivity compared with commercially available Al2O3C. So this is only one example I have given. Since my time is over, there are another examples, phototherapy devices, the phototherapy lamps and energy saving lamps, environment friendly devices that are very much necessary. And for curing of these skin diseases also, we have developed phosphor which can be coated on light emitting diodes, and these light emitting diodes are working on 5 volts. You can program it. Presently the devices which are available cannot be programmed. Therefore here most accurate treatment, hybrid treatment can be given for the treatment to the skin diseases. These are the phosphors which are the ICMR, Indian Council of Medical Research, has provided shortlisted that proposal and will be getting. These are the publications for this. Nanofiber is another technology where the phosphor efficiency can be improved, and they can be encapsulated in the nanoscale fibers, and these fibers can be used in adverse situations like the temperatures below 0 degree, below 30 degrees centigrade, as well as in ocean also. You can have radiation monitoring and so on and so forth if you process your phosphor material in nanofiber. And solar photovoltaic is the main important things that Dr. Moril sir has talked many times on this. I will skip few transparencies here. I am just the research cells, that is whatever solar cells that are being designed with different technology have reached to their limits for the efficiency. And further, solar photovoltaic efficiency is to be improved, and that is very much necessary, but there is a limit. And we suggested that we can have nanophase materials. There are publications. We are working on the practically that the same solar cell which is being, solar panel which is being erected in your house, that can be coated with the nanophase materials immersed in Teflon coating, and thereby increasing the efficiency of the solar cell, quantum cutting behavior. Similarly, we are trying our level best to find out the host to absorb the energy belonging to UV region, that is outside of our atmosphere when satellite goes no. So these solar panels are coated with the anti layer, the layer which is protecting solar cells from UV radiations. So UV protecting layer is to be coated on the solar panels. We have asked these ISRO people that we give you nanophase and be dispersed in that, and those materials can be dispersed material you can coat on the solar cell so that your solar cell efficiency will improve. If it is being improved twice, then the size of the solar cell panel required for the satellite will be less, and therefore the fuel required for such a satellites will be very, very less, and therefore a new technology, environment-friendly technology, can be adopted. Now, these are the publications which I will show here, which are being done. these are the materials, and these materials are been successful materials are shown here, how full width at half maximum can be improved for improving the solar cell efficiency of the material. So this is what the things which are being done by my students. I thank all those students who are working at. We have got these facilities at our destination. Facilities are some facilities like SAME and TEM. These are being taken from Nagpur or Jalgaon. One can get a free access to these facilities. These facilities are for the students. And one more facility which is being created, a collaboration with Beijing Synchrotron Radiation Facility BSRF, where we can get the facility of 172, 148 nanometer. And we have got collaboration with them since October 2013. This is a collaboration later from Professor Tao, and since then my students are working. Some Jaiswal, Shailesh Jaiswal is presenting on visible quantum cutting. In his oral presentation, he will give more idea regarding this. I will be very much thankful to all these students who are displayed here. I am very much thankful for giving me the opportunity. I tried my level best to improve the qualities, reflective as well as selective qualities amongst the students, that dedications with cooperativeness. Unless and until you are cooperative, your dedications will not be useful. You can commit, but you should be loyal to your commitments. And you may be intelligent, but unless and until you are motivated, that intelligence will not be useful. And you have a discipline with attitude. So with attitude, if you have got good discipline, administration, then only it will be pressed. And you may be having innovative ideas, but that lead to creative, not destructive. And you should be having systematic organization, but that systematic organization should be logically visible. And that is what I tried my level best to put those things in my students. I'm very much thankful to all my students for making me at this particular. I'm very much thankful to each and everybody for listening to this particular presentation silently. These two words are having same characters, but their sequence is different. And therefore, I am very much thankful specifically Praveen, P.T. Hamzade, and the NR Pawar for giving this particular opportunity, and Sanjay Doble, who is a 2% scientist. He is the right man behind Dr. NR Pawar to modify schedules and all those things. I'm very much happy to be associated with this particular platform. Thank you very much.
Thank you, sir, for your nice talk with all excellencies. It's a great pleasure to have Dr. Mahavir Singh, sir. I request you, sir, to kindly address the conference.
Good morning, ladies and gentlemen.
Yes, sir. Okay, sir. Very good morning,
welcome
sir.
on board. Inaugurator Dr. Apsi Raghuvanshi, Chief Guest of this conference, Dr. O.P. Chimankar, Chairman of this conference, Dr. A.N. Garde, Co-Chairman, Professor A.B. Patel, Guest Honor, Dr. A.B. Lad, and Keynote Speaker, Dr. S.K. Omanwar. It is with great pleasure that I extend a warm welcome to all the participants of the Raman 2021 International E-Conference on recent advances in material science and nanotechnology, going to be held in the beautiful town of Maregaon, Maharashtra during 7 to 9, 2021. The quest for the knowledge has been from the beginning of time, but knowledge only becomes valuable when it is disseminated and applied to benefit humankind. It is hoped that Raman 2021 will be a platform to gather and disseminate the latest knowledge in the recent advancement in emerging area of diversified research fields covered during this conference. Academicians, scientists, researchers will be able to share and discuss new findings and applications of engineering and science. I hope that participants enjoy the conference and have a memorable experience in Maregaon. It is envisaged that the intellectual discourse will result in future collaborations between universities, research institutions, and industry, both locally and internationally. The field of material science and nanotechnology is rapidly growing, and several discoveries call for renewed attention in involved researchers. This gathering under Raymond 2021 aims to stimulate the scientific discussions between the researchers, promote new international collaborations, provide a friendly platform to share scientific knowledge, and prioritize and future efforts that are needed to revolutionize, revolutionize and field of material science. And composite is a fairly tale like marriage between a variety of materials and fillers. A nanocomposite is a step future with the fillers in the exciting nano regime like in marriage. Here too, the challenges are the apparently yet exciting in order to realize the maximum potential of the nanoscience and nanotechnology. Quite often, it is conveniently to amended the nanoparticles in a matrix, forming a nanocomposite. In addition, incorporation of the nano-sized particles in the matrix would dramatically improve the properties like mechanical properties, including strength, modulus, and dimensional stability, electrical conductivity, dis- decrease gas, water, and hydrocarbon permeability, flame retardancy, thermal stability, chemical resistance, optical clarity, it is etc. The applications range from microelectronics to food packaging through automotive and aircraft. The main challenges lies in the appropriate surface modifications of the fillers to facilitate the matrix to retain the attractive properties. This conference offers a platform to interact, discuss the challenges, and the exchange expertise towards the building a possible collaborations. The topic covered in the conference are very comprehensive, which include list of 16 topics on the leading edges current research in areas comprising mineral metallurgy and nearly all the categories of the materials and the nanotechnology. The subject matter of the topics will cover fundamental physics and chemistry, modeling and the computational experimental techniques and industrial applications. The conference will feature several keynote plenary invited speakers who are the internationally recognized experts in their discipline of research. The conference will provide an excellent forum for the exchange of idea, scientific interactions, and the potential of the collaborations. In particular, the multidisciplinary natures of many topics should provide insights into the emerging frontiers in material science and nanotechnology. I trust you will have a very productive time at a conference and a memorable experience in Maregaon. Just to underline how materials represent a very promising role to develop novel economic and environmentally friendly industrial process. Thus, the adjective sustainable appears more appropriate for novel industrial process for which both economic and the environmental aspect must be considered if we want remove relevant drawbacks of some current process, preserving the added value and having real application perspective. To achieve this goal, a multidisciplinary approach is necessary to be able to revise critical and existing literature and develop new idea and collaborations focused on open new scientific course. From this point of view, Raman 2021 represent an exciting opportunity to meet different competencies and the establish contact focused to develop new research collaborations. Thus,
माझा
welcome
मोबाईल कुठे
and
ठेवला तो?
enjoy the meeting. Thank you to all.
Thank you, sir, for your motivational speech. You are the source of inspiration to number of scientists in the world. Thank you, sir.
Welcome.
By the permission of honorable respected inaugurator, I will share all the published paper under the conference label, proceeding of the conference, abstract book, and all the relevant documents of Raman 2021.
There is no audio. Is there anybody to?
Nobody there.
Yes, sir. No, sir. No, sir.
There is no audio. Nobody is speaking.
No,
Therefore,
sir. Just I have sharing the screen, sir.
Okay. Thank you.
Screen, all the published papers and the abstract book of the conference, sir.
Okay.
All the paper published in the journal as per the commitment given by the Raman 2021 and the abstract book. Certificate is also available here. I will share the link in the group and also on your register email address. Thank you and congratulations to all. Now I request to Dr. Amit Bansod sir for the vote of the thanks of the inaugural function. Bansod sir. Hello. Bansod sir.
Unmute करा Bansod sir. झाला.
Now it is unmuted, sir.
Bansod sir.
Yes, sir. Yes, sir.
Yes, sir.
Thank you, Pawar sir. So, good morning to all. I feel honored and privileged to get an opportunity to propose a vote of thanks on this special day, which is the inaugural day of the International Conference on Recent Advances and Material Science and Nanotechnology called Raman 2021, which is been scheduled on February 7 to 9, 2021. The thanks due to the inspiration behind this conference are the major patron, Mr. Jeevan Patil Kapse, the chairperson of शेतकरी शिक्षण संस्था मारेगाव and co-patron Mr. Advocate Sudhir J. Damle sir, Secretary Shivaji Shikshan Sanstha Maregaon. Then I also thank the organizing secretary of this conference, P.T. Hamzade sir, HOD Physics, PN College, Pusar, with the great support and contribution from our chairperson, Dr. A.N. Ghade sir, Principal, ACS College, Maregaon, and co-chairperson, Professor A.B. Patil sir, Principal, PN College, Pusar. This is the biggest day that we have hosted this conference at the Maregaon on e-platform, and I again thank to all the dignitaries that are available online right from 9:30 a.m. Special thanks to Professor Vladimir Petrov from Sarato State University. Under his busy schedule, he spared this time with us, is from Russian Federation. Then on behalf of the Raman 2021, I convey my regards and heartily thank to our chief guest, Dr. O.P. Chimankar sir, for highlighting the necessity of cooperative atmosphere and linkage among the society, teaching and non-teaching staff for organizing such event. Then I also thank to the honorable delegates right from our inaugurator, Dr. F.C. Raghuvanshi sir, Dean, Faculty of Science and Technology, Sant Gadge Baba, Amravati University, who has started his speech from the nanotechnology pioneering words like Bhasma, which was there in Ayurveda. He also pointed out the importance of research in the materials in nanotechnology and modern materials, the patterns that can be done, and the useful or fruitful patterns that could be transferred for or under the technology transfer process. The thanks are also due to our beloved chief guest, our beloved chief guest, Dr. O.P. Chimankar sir, then guest of honor, Dr. Mahavir Singh sir, Principal Scientist, CSIR NPL, New Delhi, and Dr. A.B. Lad sir, Professor and Chairman of Board of Studies in Physics, Sant Gadge Baba Amravati University, Amravati. Then I also thank to our keynote speaker, Dr. S.K. Omanwar sir, UGC BSR Fellow, Senior Professor, Sant Gadge Baba Amravati University, Amravati. In his keynote address, he gave us tremendous flow of the work, the direction, the path of the research that should be for the betterment of the society, highlighted some patterns that are being granted by the people under his able guidance. Also, he noted down the budget analysis in 2020-21 for research grant perspective, the research that is being done under his able guidance, like environmental, the OSL material, the skin disease, and solar cell solutions. I also thank Dr. A.N. Ghade sir and Dr. A.B. Patil sir once again for their immense cooperation for organizing this event in the small rural area, Maregaon, but I would like to share my views. Like Dr. F.C. Raghuvanshi sir said that the conference cannot be conducted at a very small place, but I remember that Dr. Pawar sir has successfully organized such a conference in a year past also. So I once again thank you, Dr. Pawar sir. I also thank Dr. Wagule sir, Dr. Dhoble sir, Dr. Yadva sir, S.S. Kadam sir, and various eminent personalities that are available here to share their views in this 3 days international conference. I thank all the participants that will share their work, views in different topics in research on this platform and spare their valuable time with us. I, in the capacity of co-coordinator of this conference, thank you all once again. Thank you.
Thank you, sir. With this, we conclude with the inaugural session of this Raman 2021 and proceed toward the technical session 1. Now I request to Dr. Ritesh Kore for technical session 1. Kore, sir.
Yes, sir. Hello.
Yes, sir.
Am I
Proceed,
audible?
sir. Yes, yes, right, sir.
So thank you, Dr. Pawar, sir, for giving me this opportunity to introduce about this technical session one. Distinguished guests, conference delegates, students, participants, and the faculty members all over world, India, and also. On behalf of this Raman 2021, once again, I welcome you all in this technical session one that is going to start very soon. So indeed, it is a matter of great pleasure to welcome you all in this technical session world. How different this morning is. Before 3 months ago, we have started the planning of this conference, and today you can see it has gathered a very big gathering of intellectuals. And now, today, we can see as we are experiencing the beginning of something interesting in the very short span of time. So, not taking so much of your time, we are fortunate to have the chairman for this technical session one, Dr. A.U. Bajpai, sir, HOD, Physics, Arts, Commerce and Science College, Amravati. So, may I now request Dr. Bijwe, sir, to please welcome the chairman of this technical session, Dr. A.U. Bajpai, sir.
Welcome, sir. On behalf of ICT. Thank you. Thank you.
Thank you, sir. Vajpayee, sir. Thank you.
It's okay.
Distinguished guests, conference delegates, we have total 3 invited talks in this technical session one. First one is from Professor Vladimir Petrov, Taratu State University, Russia. Dr. N.S. Dhuble, ma'am, Professor, Department of Chemistry, Sevadal Mahila Mahavidyalaya, Nagpur. And Dr. Devraj Singh, Director and Professor, Professor Rajendra Singh, Institute of Physical Sciences for Study and Research, Purvanchal University, Jaipur. So I request the chairman of this technical session, Dr. A.U. Bajpai, sir, to please conduct this session. Please.
Thank you, sir. First of all, excuse me. First of all, I congratulate Dr. N.R. Pawar for.
You are not audible.
Is it?
Ashwini Kumar,
Yes, sir.
your voice is not reaching.
1 minute, sir, please. Is it okay now?
Yeah, now it is okay.
Okay, okay.
Fine now.
First of all, I congratulate Dr. N.R. Pawar for this what we say successful organization of this particular conference, and the name also, the acronym also, Raman 2020-21. Honorable Guru Varya and all the participants and all the stakeholders of this particular conference. Now, I am thankful for to Dr. Pawar for giving me this particular responsibility. And now there is a talk by Professor Petrov, and I just introduce him. What I got the information is what we say in the form of titles only. There is more description to what we say introduce him, but due to time constraints, this Professor Petrov has received diploma of engineer and the degrees of candidate, and then the doctor of physics and also mathematics. the good combination. He is radio physicist from Sarato State University in 1977 and up to 2000. He got academic status of professor from Russian Federation Ministry of Education in 2002. He is currently a professor of applied physics, chair of Sarato State University. His scientific interest concern to optical information processing, optical and acoustic holography, 3D information displays, its development, high frequency acoustical microscopy and tomography, acoustic optics, opto electronics, and others. He has more than 100 papers, international research articles to his credit, and has a 4 monograph and he is holding 30 patents. He is the fellow of SPIE, that is Society of Photographic Instrumentation Engineers. He also currently working as Director General of Spectro-Acoustic Corporation. That company has one minute. There is a technical problem, I think so. Hello.
Sir, you are audible.
Sets it okay there.
You are audible, but video is not there.
Yes,
Yeah,
sir.
it's okay now.
He is the Director General of Spectro-Acoustic Corporation. That company has research and development under his guidance, and the research and development in high frequency acoustic and optoelectronics, acoustical microscopy, acoustical tomography, and all related fields. I heartily welcome Professor Petro and just invite him to proceed for his talk. Thank you very much.
Thank you. Thank you very much.
Happy, sir.
Thank you very much,
Yes, sir.
colleagues.
Yes. Memento is ready, sir.
Okay. I request who is there, please?
Myself, sir.
Okay. Oh, sorry, sir.
Okay, sir.
I request for Dr. Pawar, sir, to please honor Professor Petro. Please.
Thank you, sir. Virtually. You are most welcome, sir. Okay. Yes. Thank you, sir.
Thank you. Thank you very much.
Yeah, thank you, sir. It's proud
Okay.
moment for us, sir.
Sir, welcome, sir, please.
Okay.
You can proceed, sir, please.
Thank you very much, dear colleagues, and good morning.
Very good morning.
And I'm very glad to see you all. And thank you very much for invitation to make a presentation on such a big forum as Raman 2021. And of course, I'm very glad to hear all these talented people. And of course, I have appreciated the brilliant talk of Professor Srinivas Onwar. And it's, shows deeply knowledge in such a wide range of science. And well, I have appreciated it. Well, thank you very much. Of course, I thank N.R. Pawar, Dr. N.R. Pawar, for organization of such a big forum. And well, thank you very much for invitation. And of course, Dr. Chimankar also for send me an invitation, and well, I have appreciated. Well, thank you very much. First of all, I would like to say a few words about, let me show the display. Well, can you see my presentation?
No. Just will try.
Can you see the presentation of the
No,
acoustics?
sir. No. Just to share the you just share the screen.
So
you have to click green icon. Green
icon, share screen, sir.
But when I put the bottom green icon, show the screen.
Share screen. Share screen.
Share screen.
Share screen. You can press. You can press the share.
You can press share screen. You will get multiple options on your screen. If there are 2 or 3 files which are being opened at your destination, then all these files icon will come, and you have to select one out of that. Yeah, now it is coming.
Yeah. It is visible now.
Is it okay now?
Yeah.
Yes. It is visible, sir.
Oh, okay.
Thank you.
Again, it's optoacoustics, while instrumentation for energy input and output. Optoacoustics is the science which allows to investigate materials. So it's the science which allows to show the particular properties of materials. That's why I decided to tell about this science a little bit. So, but first of all, I would like to and this is the plan of presentation, to say a few words about the region of our city, of our university. So this is the map of Russia, and the right point is shown Saratov city. Saratov city is situated on the bank of the Volga River. So it's a view, you see it's a Volga River. It's the biggest river in the Europe. And well, another map shows the distance between our cities. So Yavatmal and Saratov, there is a way of 4,400 kilometers. So it's not far from, in fact, from each other, but well, up to now we have to, well, see each other by electronic system, by internet. Well, Saratov city is situated on the bank of the Volga River. It's the biggest river in the Europe and has plenty of islands and many fishes and well, good place for the rest. So you are very welcome to Saratov city. I'll be glad to see you in Saratov. And this is a bridge over the Volga River near the Saratov city. And this is our university, the main building of the University of Saratov city. Our university has 20,000 students, 13 faculties, 15 R&D institutions. So it's a rather big university, and this is the library of the university. It was built in 1909 by architecture Müfke, German architecture Müfke. Little bit more information. This is the conservatory of our city and some churches. Rather beautiful city, Christian churches. So you can see, if you come to our city, you can see many beautiful places there. Okay. Now about optoacoustics development. Optoacoustics is the rather old science, but also it's rather young, because from the beginning of discovery of photoacoustic effect by Alexander Bell in 1880, passed some time, well. But after that, there were some rather deep researches in that field. And in modern time, there were appeared several books about this science. The book of Professor Zharov and Letokhov, the book of Professor Karabotov and Professor Gusev, and so on and so on. Professor Arayevsky also. And what means optoacoustics? Optoacoustics means the transformation of optical energy to acoustical energy. And after that, it is possible to get the signal, acoustical signal, that carries the information about properties of materials, because optical pulse allows to generate several acoustical modes. So it is surface acoustical modes, the bulk acoustical modes, which propagates in different directions. And it is possible to get the information using the different kind of acoustical devices, receivers, like microphones and like piezoelectric transducer and so on and so on. So it is a very rich instrument to get the information about material properties. So in my talk, I would like to attract the attention to different possible ways to use different approaches to get the information from this unique instrumentation. So first approach is spherical approach, to use spherical lenses to collect the acoustical waves. So it is scheme shows that optical beam, in fact, it is pulse beam pushed to the sample, and on the boundary of between two media, the acoustical waves are generated. And these acoustical waves can be received by acoustical receiver. So in this particular case, it is used spherical acoustical lens, which represents the rod of quartz, and on the butt end of which the piezo transducer is situated. So on the picture, we can see some examples of such kind of spherical transducers, which are produced in our laboratory. So this particular transducer, the case made on the, and acoustical lenses also made on the titanium, and the parameters are 8 millimeters diameter, and central frequency is 5 megahertz. Another example of spherical transducer made on fused quartz with the cavity of just 500 micrometers, so it's a rather small cavity, and the central frequency is 1 gigahertz. So it is rather high frequency, and it is possible to get the information with very high resolution of the property of materials. Well, next approach is coaxial approach. It was very interesting to use such kind of approach because in comparison with between two receivers or radiators, in one case it is a disc shape receiver, and in another case is ring shape receiver. There is some privilege to use ring shape because it is the relationship between zero order and first minus and plus first order relationship. So in our case, we theoretically and experimentally showed that such kind of approach can be used for creation the optoacoustical receivers, which combine several tasks. First, to get the information, acoustical information from radiated waves by optical pulse. And optical pulse can be passed the energy through the optical fiber, which is put it to the channel in the axial channel in the quartz sample. So on the butt end, there is a piezoelectric transducer is situated, and besides, it is possible using this channel to put the water, which in fact is the immersion liquid, so that to allow the acoustical radiated acoustical wave to to reach the lenses of acoustical receiver. Well, on the picture you see the coaxial optoacoustical lenses, which produced from fused quartz, and there is a channel. You can see also channel for liquid, immersion liquid, and for optical fiber, which is possible to put here optical fiber and pass the energy through optical energy through this fiber. The setter frequency of such device is 100 megahertz, and transducer is made on the lithium niobate crystal. So on the photo, you can see well, such kind of objectives with optical fibers. So on this picture, you can see also such kind of device with the tube for immersion liquid. Next interesting approach, to use the cylindrical acoustical lens. It is possible by using such approach to combine in one device the acoustical receiver and optical focusing system. It is possible by using the optical fibers to deliver the optical energy of different wavelengths to the same device, and for realization of optoacoustical spectroscopy method. And this method allows to get very rich information about the sample properties. Such experiments were made on our laboratory, And on the picture, I can see optoacoustical set, which combines the acoustical lens and optical lens, and there is connectors for radio frequency energy and connector for optical energy. And this is such device in more detail. On the picture, you can see some parts of such a system, which represents the radio frequency connector, acoustical glass lens, and the objective case, and so on and so on. And there are also such kind of devices and the elements of this device. On this picture, you can see the ring-shaped piezoelectric transducer with silver electrodes, which allows to collect the information, acoustical waves, and transform it to electrical signal, and then to analyze it by the computer. Next sample of cylindrical approach is to combine in one crystal the acoustical and optical lenses. So the optical beam is focused by the same lens which is used for collecting acoustical waves. You can see the crystal. This is lithium niobate crystal. On one of butt end of this crystal, the cylindrical lens is realized, and thin film transducer, thin film piezoelectric transducer is spattered on this surface of the crystal. And there is the window for optical beam in it. And this particular scheme of investigation devoted to the investigation of cancer and vessels. So you can see the cell of the cancer, which in fact has the dark color, black color. So normal blood cells normally has white or red color, but cancer cell has a black color. And that's why it absorbs the optical energy and radiates the acoustical signals. And it is possible to catch the time of appearance of this cancer cell. And after known time, to switch on the device which can destroy this cell. So in fact, it's a kind of theranostics. On the picture, you can see an example of such cylindrical lenses which produced from the lithium niobate crystal, and thin film made on silicon oxide. The thin film transducer made on silicon oxide. Central frequency is 1.25 gigahertz. And optical transparency on this crystal is 0.4 to 5 micrometers. So again, the scheme of such kind of experimental setup for investigation of cancer cells on the vessels of the human body. This is the photo of experimental setup. And well, you can see the optical lens and acoustical receiver and the phantom of the vessel. You can see the vessel here, phantom of vessel. On the picture, you can see the parameters of light source, the laser with a wavelength of 1064 nanometers and pulse duration 600 picoseconds, and the width, pulse width in nanoseconds, 1.5 nanoseconds. Pulse energy when we have modulation rate 2 kilohertz, 1 kilohertz, and so on. Beam diameter is about 2 millimeter, and divergence is about 5 milliradian. On the screen, there is the response of the signal. The experiments was made on the Arkansas University in the framework of mega grant supervised by Professor Zharov. Next interesting approach for using of optoacoustics is to combine HIFU, high energy focused ultrasound with optoacoustical methods. This method allows simultaneously in real time to investigate some particular properties of object well behavior or object well property of tissues. And then when we find say cancer tumor, it is possible to focusing on this particular point and then switch on the acoustical energy and destroy this cancer tumor. So, and this experiment can be done in well real time and in vivo regime for animal. This is a rather interesting approach, and we can use it in our experiments. And next part of my talk concerns the ultrasonic tomography, which can be also combined with optoacoustics. And this is also very interesting instrumentation and for material investigation. This particular device was developed in our laboratory, in our company, for aim of for space aims. So, in fact, this device is devoted to use in the spaceship to investigate the cover of the spaceship, which normally made on the aluminum metal and aluminum material. And this is electronic block, and this is scanning, mechanical scanning system and the computer. Well, this tomography system has specific objectives, which allows, you know, that to get the information from ultrasonic waves, it is possible to provide the immersion liquid between the investigated object and the ultrasonic objective. Normally, when we use, say, ultrasonic microscope, acoustical microscope, the object normally they put to the water, so that to provide the connection of transportation for of acoustical waves through the water from the object to the objective. But in the space, normally in the space and in the cabin of cosmonaut and astronauts, it is not possible to use such a basin for the water. And for this, to apply such device in the space, we invented special system to put the immersional water, immersional liquid, drop by drop, exactly to the cavity of the lens of the acoustical objective by this tube. And the construction of this objective allows to put water through this tube exactly to the area of cavity of acoustical lens. And there is a radio frequency connector, and this is tube for the water. So this split part of the system, which allows to change the objectives with different focus distances. Central frequency of such kind of objectives is 100 megahertz. The transducer made on crystal of lithium niobate. And there are different focus distances, 5, 9, and 12 millimeters. So now results. So you can see the aluminum plate, thickness of 5 millimeter. Well, and on the back side of this plate, there is the sign AT 2013, and the deepness of this relief is just 10 micrometers on the back side of the aluminum plate. And we can read by using this our acoustical tomography system, we can read this this sign through the aluminum plate. Well, on the picture we can you can see different defects on the surface of the sample, and some of these defects are situated on the backside of the sample, and it is possible to see the defect through through the thickness of the sample. And this is also testing of scratch. This is 3D image of 2-diameter cone made on alumina plate. with depth of 2.48 millimeters. And you can see the acoustical image, 3D acoustical image of that cone made by tomography system. And now, if we put the objectives which allow to use the optical fiber here, and it is possible to transform this acoustical ultrasonic system to optoacoustical tomography. And that instrument allows to get more information, more and more information about the property of materials. Well, this short talk is over, and well, I would like to thank all participants for listening, and well, I'll be ready to answer questions. Hello. Well.
Hello, sir.
Hello.
It is 3D capturing using of method of sound tomography. Is it?
Yes. Yes.
Tomography is like CT scan. Can you have this layer by layer?
Yes. Yes. Sure. Yes, it is possible to get the information layer by layer. Yes. Sure.
Yeah.
Of course, and we find some interesting peculiarities of the material inside the system. Yes, exactly. It's a kind of holography.
It will be very useful in medical sciences, no?
Yeah, sure. In medical sciences, in the space, and atomic energy science, and so in a wide range of difficult technologies.
Thank you, sir. Thank you very much.
No more question? Okay, thank you. Thank you very much again.
Thank you very much, sir. Hello.
Sir, allow the PPT. Yeah.
Hello.
बस.
Ashwini Kumar. Hello, Ashwini Kumar.
No. It's a good video. Start video.
Hello.
Yes.
Ashwini Kumar.
Yes.
Please make a comment on the
Yes.
presentation and say a few thanks. Then you start second.
Yes, of course. Yeah. I am very much thankful, Sir Pedro.
Speak loudly.
Yes, sir. 1 minute, please. I am very much thankful to Professor Pedro. He has very nicely given this information and related to the combination of sound and the light, optoacoustic. Since there are no questioning from the audience, I am thanking him on behalf of Team Raman. Thank you very much, sir. Please. Hello.
इंटरनेट कनेक्शन अनस्टेबल म्हणते
तू लाव ना आवाज येऊन राहिला तुला
Am I audible? Hello.
Sir, yes, sir. Yes, sir.
माइक सुरू आहे
Sir.
Yes.
Badri sir.
Yes. Hello.
You may start.
Yes.
IT1.
Okay. Now I welcome Professor Dr. N.S. I request Professor N.R. Pawar.
Sir, Professor Dobre sir. Dobre sir.
Professor is there. Wow.
Yes, yes, right, sir.
Yes.
This is a nice combination, sir. This is
Yes, sir, of course. I request Professor Dobre sir, please, to welcome ma'am, please. By honoring him a memento.
Hello.
Hello.
Sir.
Hello. Dobre sir.
Yes. Ma'am, you are audible.
Yes, sir, please.
Yes, you are audible.
I offer her a memento, please.
Sanju should offer.
Yes, of course.
Memento.
Yes.
Yeah, the memento is yet to reach. Yes, it is yet to reach because of Krishna.
It's okay.
So,
we have a grand
proceed.
welcome, madam, here. And just I am introducing during the time, ma'am.
Yeah.
Ma'am, Dobre. At the Department of History, Sevadal Mahila Mahavidyalaya, Maharashtra, India. She has completed
MS 198 from Nagpur University and in 19th University. She has experience of 26 years
of teaching and research at the same Mahavidyalaya and research experience of about 32 years. She published more than 83 international articles, research articles, and at international level and national level 47 articles, and in conference proceedings she published more than 44 research articles. Google in her credit is 689. She also has published 38 books related to research and the general chemistry. These books are listed in the UGC listed data. 4 PhD awardees are there to her credit, 2 registered, visit abroad. So, journal, biology, physical sciences, published by Research Academy, Sevadal Mahila Mahavidyalaya, Nagpur, Maharashtra. Completed major research projects, minor research of synthesis and preparation of and characterization of thermoluminescence, preparation of and characterization of inorganic and organic lamp phosphors, radiation dosimetry. These are the area of interest, and she is a life member of Institution of Nuclear Chemists and Allied Sciences, Indian Association for Radiation Protection, International Association of Advanced Materials, the Blind Relief Association Nagpur, the Society for Materials and Chemistry. I welcome ma'am. Sir, please, Dr. Dobre sir, S.J. Dobre sir, please. Welcome ma'am. Hello. Hello.
Thank you, sir.
Madam,
Thank you
please.
very much,
Please,
Chairman
please,
sir.
madam, you can proceed.
Thank
Yes,
you very much
madam,
for the
please
nice.
proceed.
Yes, I would like to proceed. Thank you very much, Chairman sir, for the nice introduction you have made. I would like to thank Dr. N.R. Pawar sir also, convener of this seminar conference for inviting me for this plenary lecture. I'm Mrs. N.S. Dhobe from Department of Chemistry of Sevadal Mahila Mahavidyalaya. Am I audible?
Yes, yes, yes.
Am I audible, sir?
Yes, yes.
And the
Yes,
PPT is also visible, sir?
Yes, yes.
Okay. Just a minute.
Yes, sir, take your time, no problem. Please take your time, no problem.
The talk is here now. The radiation and safety is the topic we'll be discussing over here. These are the different sources of energy as we use these renewable and non-renewable energy sources in daily life for different purposes. What are the renewable sources? What is the difference between renewable and non-renewable energy sources? That the renewable energy sources are present in plenty and can be replenished naturally, while non-renewable energy sources are limited and they are fast depleting. That is the main difference over here in these two. What are these different sources? The non-renewable sources are, as we know, oil, coal, natural gas. All together are referred as fossil fuel, and the remaining is nuclear energy. These are the different non-renewable sources, while the renewable sources are wind energy, geothermal energy, solar energy, hydropower, and biomass, and some others. Now, out of these oil, coal, natural gas, there is the fossil fuels which are being used worldwide. Nearly 80% of the population of the world mainly depend on these fossil fuel. But the fossil fuel, the main problem with this is that they are giving carbon emission and they are contributing this carbon emission to the environment, and which is responsible for the global warming over here, and hence they are also fast depleting. Therefore, some other alternative has to be chosen, and therefore a nuclear energy can be a good option over here. Now, in these renewable sources of energy, all other sources except solar energy, they have a bit limitations. Large amount of energy may not be generated, and they have their own limitations. But the solar energy is a very good option. A lot of research is being carried out, and of course, plenty of, as a source of solar energy is sunlight. So plenty of sunlight is available, and therefore it can be very nice to have some disadvantages, a little bit disadvantages, because number one, it is a cost wise, it is slightly cost goes higher. Secondly, the energy cannot be, this energy cannot be stored, and if it is stored, again it is a costly affair. And thirdly, a large huge space for the solar energy. So though it is a good option, it is slightly costly, and therefore nuclear energy, which is a clean source of energy, and large amount of nuclear power can be generated using this nuclear energy without carbon emission. Dr. And behind Pokhran 2, that is Dr. Abdul Kalam, former President of India, has rightly said that India must go for nuclear energy as it is a clean and green source of energy. Further, he said that if India wants to prosper its future, this is a very good way of getting it. India is also blessed with large amount of thorium, which can be used as a nuclear fuel in nuclear reactors. And this amount of thorium which is present in India, that is in southern parts of India, it constitutes nearly 1/3 of the thorium reserves present in the world. So India is blessed with large amount of thorium, and therefore nuclear energy can be created using this thorium which is in India. And he rightly said, that is Dr. Abdul Kalam said that I support, he used to say that I support a nuclear energy being clean and green energy, along with, of course, solar energy and wind energy. So understand this nuclear energy, what are the benefits of it, what are the advantages of it, we should see this next slide. Why nuclear energy must be a part of energy solution? Because there are lots of advantages. Number one, that is it is the largest source of clean power, no carbon emission and hence no global warming. It is the most reliable energy source. It of course protects air quality because again, no emission, no gaseous emission, no carbon emission, no CO2 emission. It produces very little waste, and this waste can be very well used properly, and this produces more electricity on less land than any other clean air source. I would like
Sir, please, Pawar sir, please. Hello. Hello.
I think, sir, connectivity issue.
Maybe. It's okay. It's okay.
Right. Yes, Raj, sir. Yeah. Okay, sir. Ma'am, please unmute yourself. Doble, sir.
Hello. Tell madam to unmute, please. Hello.
Okay. Slide,
हाँ, sir.
please. Please clear.
No.
क्लियर है क्या?
नहीं.
Okay. Okay, I will
Unmute
share
करा.
again.
Unmute करो.
Okay.
so let us see the challenges for this nuclear chemistry. The number one, which is very important, is the public awareness. There is very little public awareness for this nuclear energy. It is this new.
Sir, please look into the matter, please. Pawar sir.
Again, sir, same issue.
Okay, it's okay.
Connectivity. Our connectivity is very strong, sir. No problem, sir.
No doubt.
No doubt, sir. 100%. Sure. Doble, sir. Hello. Hello. Yes, yes, right. Ma'am, your screen is visible. Unmute yourself, ma'am. Okay, sir, unmute. Okay.
Sorry for the interruption. Net was not working. What are the challenges over here? As I said, number one, the public awareness is very much required, and a role of teacher is important over here. He can disseminate the clear-cut information and the knowledge about the nuclear energy to the students as well as the public. And the second challenge, which was important, is about the used fuel and its transportation, its storage and disposal. Let me tell you that nuclear fuel can be very well managed and it is always secured by Department of Atomic Energy. There is no problem for transportation, storage or disposal. Now, what are the different types of radiations which are associated with nuclear energy? We shall see. Actually, radiation is a fact of life. The mankind has been living in naturally radioactive environment since the beginning. As we get exposed to sun, outer space, the radiations are always there. Radioactive materials in the earth, where radiations are always present in the houses we live in, buildings, food, drink, what we consume, and air also. So radiation is inevitable. It is always there over here. Here is a picture that shows that radiations are present in house, walls, and etc. Not only that, it is also present inside the body of a human. Potassium, 40 potassium is present over there. So different types of radiations as shown already, that cosmic radiation, it consists of high energy protons, alpha particles, neutron, neutrinos, photons, electrons and heavier particles, and from all these different types of particles we get exposed to the radiations, which is inevitable. It always takes place. Another kind of radiation, that is the terrestrial radiation, that is from houses where we live in. Gamma radiations are present, radon and thoron mainly, they are present in the earth crust. They are also present in the closed room, and they also depend on the ventilation. If ventilation is proper, radon concentration or the dose is less, otherwise it is very high. Then various kinds of radionuclides are always present in the Earth's crust, and gamma rays are always emitted from the Earth crust. And secondly, the radon is also always there, and its daughter products are always there, which are emitting alpha and beta particles. And so we are continuously getting exposed to these radiations. And as I told you, that internal dose is also there for a human being. 40 potassium is there, which it is ingested along with the food and water, and our body itself contains 2 grams per kg weight of a potassium. Now different types of ionizing radiations are there. So a man or a human being is continuously getting exposed to these ionizing radiation sources. These sources can be of two types, that is natural background and man-made sources. And one has to remember that human beings have always been exposed to the radiations from our environment and from the materials within our bodies. There is a natural background radiation which is always there, as we have seen different cosmic, terrestrial radon and internal sources of radiations, and the total dose from all these natural sources constitutes 2.4 millisievert. What is how much? 2.4 millisievert is the total dose from the natural sources, which is inevitable. Here also, this slide shows that as the distance from the sea level increases, more and more radiations are being exposed. As a human being or a person is exposed to more and more dose over here. Further, let us see the second type, that is, up till now we have seen natural radiations. Now let us see the man-made radiation sources. What are they? Number one is medical diagnostic exams, that is X-ray, etc. are used for medical diagnostics. For some more radioactive isotopes, that is potassium, technetium, etc. are used for medical diagnostics, scanning, etc. for the purpose of scanning, etc. So around 0.4 millisievert is the dose that can be exposed or that can be absorbed by a person working over here or finding examination. Then atmospheric nuclear testing is there. Chernobyl accident, nuclear power production, they contribute uh, the doses in millisieverts which are mentioned over here. And if we make a total of all these man-made radiations, it is almost, or it is 0.4 millisievert or so. Remember, 0.4, more than of course 0.4, but 0.4 millisievert or so. However, natural background radiation constitute 2.4 millisieverts. So one can see that the natural background radiations are more than man-made radiation sources, and one is getting exposed to the more dose than natural background. So these are the different areas where doses are higher. India is second, Brazil is first, where monazite sands are present. In Kerala, we have nearly 15.7 millisievert dose. So these are the different types of average radiation dose levels. The perspective is there. Further, what are the ill effects of this radiation? One should always know. There are two types, that is somatic effect as well as genetic effect. Somatic effect are effects that are seen in the individuals, while genetic effects are the effects which are seen in the individual. Along with that, its offspring also suffer from those effects. Then there are deterministic effects, that is whenever gamma radiations are used or cobalt-60 isotope is used for cancer treatment, skin burn is there, falling of hair is there. These are the examples of deterministic effect. And the main is they are related to dose, that is more the radiation dose received by a person, more will be the effect. Okay, but another is stochastic effect, where they are not dependent on the dose which is received. Whether the dose received is less or more, these are going to happen over there. So cancer is an example of stochastic effect over here. So these are the different levels of doses, and if the radiation dose increases up to 3500 to 5000 millisievert, definitely 50% of the exposed person will die with radiation sickness within 2 months. So these are the ill effect of the radiations. So basically the recommended dose limits are there. For public, it is 1 millisievert per year. These are recommended doses allowed. While the personnel who are working in the nuclear power plants also, their limit is slightly higher. 20 millisievert per year, which is averaged over 5 years, is allowed for such thing. However, annual dose from the radiation is 2.5 or 2.4 millisievert, remember. Now what, as I told you, the radiations are having ill effect, which already we have seen, but it also has got some beneficial effects, because of these radiations or nuclear energy, one can produce various radioactive isotopes like iodine 131, iodine 125, technetium 99, etc., cobalt 60. These are used for diagnostic and therapeutic use over here. And main contribution from cobalt 60 is for the sterilization of various food products, which is very, very important. So these are the positive or beneficial effects of radiations. One can see here the X-ray can be used for therapeutic and diagnostic use. Nuclear medicine, where technetium 99, metastable technetium 99 is used, and this is used for taking the brain scanning, etc. This scan, an example of scanning or a brain scan is shown over here. It is very useful technique. It is also used in cancer treatment. All of us know that cobalt 60 is used, or high energy X-rays or electron beams or radioactive isotopes are used to destroy the cancerous cells. Then radiation sterilization plants are there in India. Two radiation sterilization plants are established right now, that is Bangalore and New Delhi. And of course, the ISOMED was the first medical sterilization facility in the country, that is at Mumbai, BARC, which was providing sterilization for most of the products over here. So these are the important beneficial effects. Positron emission tomography at Mumbai is also the beneficial effect of these radiations. This is again the important application of radioactive isotopes, that is cobalt 60 and phosphorus 32. These two isotopes are very much useful for the improvement of crops, that is high yielding, improved quality, disease resistant plants, or the quality of the crops can be obtained. And phosphorus 32 is also used in the plant uptake studies over here. So improved variety with a low dose of gamma radiations of the crop can be very easily obtained over here. Now we see what are the units of dosimeters and what is the recent development. These thermoluminescence dosimeters are used to measure the amount of radiation absorbed by a person. So what is the recent development? Let us see. It shows the what are luminescent materials. They find application whenever we prepare luminescent material in our lab. These materials, they find application in lighting. It also find applications in radiation dosimetry. So we are working in our labs to prepare dosimeters, which are used in they are called as phosphors, and they are used as lamp phosphors, that is they can be used for lamps. They can also be used for radiation dosimetry, which is also called as TL dosimetry. Radiation dosimetry means here the material which we synthesize is useful to find out how much amount of radiation is exposed to by a person or so. These phosphor materials can also be used in display devices, scintillators, or laser materials. So here we focus on the TL dosimetry or radiation dosimetry. But before that, what is nuclear radiations? We shall see. The emission of energy waves triggered by a nuclear reaction is called as nuclear radiations. And some of the types of those radiations which are there are gamma radiations, which are generally obtained in any nuclear energy. They are the electromagnetic radiations. And next is alpha particle radiations. Then beta particle radiations are also given along with the nuclear energy. This is another picture. Along with that, neutrons are always produced. Whenever a nuclear reaction takes place or nuclear power is generated, neutrons are always emitted. They also cause hazards to this human being. So these are the penetration power of different ionizing radiations which we have just seen. That is, a particle, it can be stopped by paper. Beta particles passes through paper or skin but can be stopped by aluminum or light metals. Gamma or X-rays pass through paper, aluminum, iron, but can be stopped by lead or heavy metals. While neutron cannot be stopped by even lead or heavy metals, but paraffin, concrete is required, or sometimes heavy water is required to stop the neutron. So this is the penetration power. So how to stop the exposure? How to stop these radioactive isotopes? So we have on the right hand side, you can see the small instruments which can measure the radiations to which a person is getting exposed. So this radiation which is exposed, it is actually called as radiation dose. And how does it work? That interaction of these ionizing radiation, that is alpha, beta, gamma, etc., with various molecules present in our body, it takes place. And when interaction takes place, ionization of the molecule, generally water is the main component of our body. So ionization, that is called as radiolysis of water, takes place. And whenever these radiations they interact, energy deposited per unit mass of the medium is called as radiation dose. And the unit of dose is here, that is 1 joule per kg, and this is generally called as gray, or it is also referred as sievert. So these are the two units over here. And the other radiation units are also there, that is depending on the use of this are the different types of units which can be used over here. This is the interrelationship between the SI units and non-SI units. That is, SI units are becquerel, gray, sievert, or coulomb, while the non-SI units are Curie, rad, rem, and Röntgen, and the interrelationship is given over here. This is also the same thing. Interrelationship is given. So dose of radiation depends on the amount of radiation energy absorbed by a body per unit mass. The pictorial description is over here, depicted over here. Now, how to protect radiation? One has to stay for a little time if radiation is there nearby. So time is important. One has to keep distance from that radiation source if it is there, and one has to use shielding. This is exactly like COVID. You have to keep distancing, you have to use mask for shielding, etc. So same principle has to be used for radiation protection. Now, what are the effects of radiation exposure on the human health? So different, depending on the type of radiation dose, different effects are produced in human body. So doses nearly for 1 sievert or so usually do not have immediate harmful effects, but more than 100 rems, that is 1 sievert, they can cause nausea, vomiting, etc. Further, this is the effects of nuclear radiation on the human body. It is shown all the organs are sensitive, but higher sensitives are generally the colon and the reproductive organs, breast and lungs, and therefore we hear most of the time that cancer of these organs is very common. It affects, of course, hair, brain, thyroid gland. It also affects, radiation also affects, radiation doses more, it affects blood system, it affects heart, and more commonly the reproductive systems. If long-term exposure of the radiation sickness, victims will become sterile. Gastrointestinal tract is also affected by this. So long-term effect include blood disorders, cataract, leukemia, cancer, and many other effects appear in 2, 3, or even 10 years afterwards. So this is the effect of absorbed dose. Just now we have seen. Again, it is given in the different way that more than 200 rats, death is definitely bound to occur over here, and probability of death increases to 100% if it is between 1000 to 200 rats. These are the different units. So over here, here one can say that if the dose is less than 5 rad, no immediate observable effect occurs over there. Then what are the long-term health effects? We have already seen that cancer is a long-term health effect which can occur. Lungs can be affected. Interstitial fibrosis or parenchymal atrophy can occur. Premature aging and cataract. And then chromosomal aberration can take place. Chronic radiodeterminatus, genetic infertility, and damage to embryo. Embryo or a pregnant woman is very much susceptible because the continuous cells are growing, and such a continuously growing cells can be very immediately affected by the radiation. So we have to take some certain safety measures over here. The effect, every effort should be made to minimize the radiation dose. One has to identify the radiation areas and one should not go nearby. And we have to understand how external radiation can be controlled over here. So this is another way to show the alpha, beta, and gamma neutrons and how to shield them. We have to increase the shielding to decrease the dose over here. Now these are the instruments which can measure the radiation dose. These are called as TLD dosimeters, and these can be available in different designs as can be shown over here. On the right hand side, one can see the material which in the center, the material which can absorb the dose, and later on that material can be heated to obtain its TL, and of course the radiation dose can be measured over here. So this measurement of radiation is referred as radiation dosimetry. And the very basic principle that is used in the measurement of radiation dose is thermoluminescence. What is thermoluminescence? All of us know that thermoluminescence is the phenomena of light emission, and upon heating this material, which has been previously excited by the electromagnetic radiation or any source of radiation. Now, when the excitation of source of ionizing radiation creates free electron hole pairs and they move over here, this results in the trapping of electrons or holes. This principle is used in this LD dosimeters. The details of these will not discuss over here. Now, many scientists in India and abroad have investigated this thermoluminescence of different materials. They studied their mechanism and found number of them useful for TL applications. These are the TL readers, that is thermoluminescence reader. Different types are present in our lab. Harsho TLD reader is another unit which is present in our lab, which can measure thermoluminescence. So thermoluminescence dosimeter are increasingly accepted for radiation dosimetry for the following reason, because it possesses these characteristics. That is, number one is existence of thermoluminescence materials having Z effective equal to 7.4 to make it nearly tissue equivalent. This material should be tissue equivalent, and it is very good. Then it should have sufficiently high sensitivity and accuracy. It should be commercially available in small size solid detectors, as already shown to you. The material should be available with excellent long-term stability. It should be reusable, etc. These are some of the characteristics. Some general characteristics of most of the common thermoluminescent materials used are also given over here. So these are the, again, characteristics I have shown: high sensitivity, emission. These are all repeated. Then easy method. These materials should be prepared or can be prepared by very easy methods. They should have practically infinite shelf life. They should have reusability. They should be non-toxic, and equivalence, which also leads to energy independence. These should be the characteristic possessed by the material or the substance which is used in TLD dosimeters. And the very important characteristic is that its Z effective should be equal to 7.42, and the effective atomic number of lithium fluoride is close enough to this, and therefore this is a LiF-TLD 100 is a very good material which can be used as a TLD dosimeter. In last decades, these are the different types of TLD materials which are reported. But the most common phosphors which are used, that is LiF-TLD 100, and another is CSO4-DY. These are the two materials which have got good sensitivity. But CSO4-DY has good sensitivity but poor tissue equivalence, while LiF-TLD 100 has very good tissue equivalence, but it is slightly less sensitive, you may say. Well, the details will omit. What is our contribution in the field of dosimetry? In our research lab, we are involved in the synthesis and characterization of radiation dosimetry phosphors using TL technique. In our lab, we have developed several phosphors which are used in TL dosimetry. These phosphors are nothing but the materials which will absorb radiation dose, and when its TL measurement is carried out, it will give a peak, and that is intensity of that peak will be proportional to the amount of radiation it has absorbed. So different characterization techniques are used whenever such a materials are prepared. Different characterization techniques are used, which are photoluminescence, XRD, and crystal structure refinement, etc. These are the techniques which are used over here. The different routes of TLD phosphor synthesis are shown over here. That is, these phosphorus materials can be prepared by solid state diffusion, Sol-Gel technique, chemical method, and acid method. And the phosphor material which is prepared by these methods can be characterized by the following techniques, that is XRD, SEM, photoluminescent, TEM, ESR, and TL and Raman spectroscopy. These are the ways in which this can be characterized. And we have synthesized lot of TLD materials. These are published in different articles which are shown over here. This is the material, that is lithium magnesium borate activated with dysprosium. This is used for gamma rays as well as carbon ion beam exposure. Now this is the arrangement of keeping the TLD dosimeters. The small dosimeters are kept nicely in such shelves. This is a close look for this TLD dosimeter. Whenever someone is working in the laboratory in which nuclear energy or radioactive isotopes are present, which emit different kinds of radiation, one has to wear this badge so that the amount of radiation he or she is getting exposed can be recorded later. So these are the badges we have used. This is a gamma chamber arrangement over here. This is another view of gamma chamber, which we use for irradiating the material while studying it. This is an example of that is DY activated strontium borate. Impact of carbon beam was seen on this material, and it is published. Another paper is published in Royal Society of Chemistry in PCCP journal. Here, the carbon-6 beam and gamma irradiation induced effect on structural luminescent properties of EU dope lithium sodium sulfate have been studied by TLPL and ESR studies. And here another picture of food processing unit is shown over here, that how cobalt 60 and electron accelerator which emit gamma radiation, and the low dose gamma radiations are always used for sterilization of food material. In foreign countries they are very nicely used over there. These are again the different designs over here, designs of TLD dosimeters, and the materials which are present in that are prepared in the laboratory. These are the again ring like structure over here. Another emerging field in India is proton therapy. Here also the dosimeters have to be used. These are the personal protective suits where one can protect oneself from the radiations, the different kind of nuclear radiations which are available in the market. Radiation safety materials are also available in the market as shown over here. These are the hand gloves, all these materials are present over here. And I would like to conclude that extremely good sensitivity of TL for detecting the presence of defects is beneficial for detecting low radiation levels which are encountered in personal and environmental monitoring. And some phosphor mentioned above, which are observed as nanomaterials, they can be applicable for measurement of low dose measurement as well as high radiation dose measurement, which are used in the accidental dosimetry case. Thank you very much for patient hearing, and I would like to extend my thanks to Dr. N.R. who has invited me for plenary lecture over here. Thank you, sir. Thank you, one and all. Thank you, sir.
Bajpayee sir, unmute yourself. Hello, sir.
Hello, sir.
Sir, unmute yourself, Bajpayee sir. Sir, you are not
Hello,
audible.
sir, I have completed.
Hello.
Sir, unmute.
Hello.
Yeah.
Hello,
Yes,
please,
sir.
audience. If you have any kind of queries, then please share. Hello. 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 Hello.
Hello.
Yes.
Sir, you are audible, sir. I think there is no any queries. Yes, right.
There may be the problem of connectivity, I think so.
Yeah,
Please.
yes, a little bit
Sir.
problem is there.
Hello. Am I audible?
Yes, yes, right, sir.
Hello.
Yes.
Yes, sir, yes,
Hello.
you are audible, sir. Bajpayee sir, you are audible.
Okay. Madam, I think if any kind of queries are there, then please share. Audience, thank you. Professor Dobre focused very well in respect of radiation therapy and its limited use. Exhaustive and more than threshold use of radiation may cause another medical issues than that of the cancer. She also have run her accelerated research with the use of luminescence materials, various and varying effects of majorly known radiations like alpha, beta, gamma rays, and also dose therapy in terms of energy radiations to be focused or to kill the cancer cells. Madam, I have one question, please. Is there any methodology to
is there any methodology to save the good cells rather than these cancer cells while focusing the radiations on a particular cancer tissues?
No methodology, I don't think so it is there, but one can control, one can very precise control can be there while operating or while getting exposed to this while taking this treatment.
Particular radiations. Yes.
Yeah, yeah.
Thank you very much. Madam has nicely explained the current topic, the topic of current relevance. I am very much thankful on behalf of Raman team. Madam, thank you very much.
Thank you so much, sir.
Please.
Thank you very much.
Hello. Now, may I call upon the next speaker, please?
Yes, sir.
Okay. I think Professor Pavde is here. Sir, please. Hello. Hello.
Yes.
Sir. Pawar sir. Hello. Yes,
Pavde sir.
Hi, sir.
Professor Pavde is there, I think so.
Yes, yes, right.
Hello.
Pavde sir, you are co-host.
Yes, sir. Okay.
Okay, sir.
Hello.
Yes, sir.
Hello.
Yes, my audio sound is audible.
Pawar sir.
Hello.
Am I audible? Please tell me.
Yes, sir.
It's okay.
Hello. Yes, sir. My sound is audible.
I just welcome Professor Dr. Vijay Pavde sir here, and I just call Dr. N.R. Pawar to please welcome him in our this room and Raman 2021, please, sir.
Yes,
who is
Pavde
there,
sir.
please?
Virtually. Okay, sir.
Hello.
Yes, sir.
One minute.
Okay, thank you, sir.
Sir.
Yes.
Hello. Sir, who is there? Please tell me. Okay. Sir, I welcome you, Dr. Vijay Pavde, sir. He is an assistant professor in the Department of Applied Physics at Lakshmi Narayan Institute of Technology, LIT, RTM Nagpur University, Nagpur, Maharashtra, India. His research focuses on rare earth doped oxide materials and its applications in LEDs and solar cell devices. He has published more than 33 research articles in referred international journals and is acting as a reviewer for many journals from elsewhere, Spingers, Wiley, Feller, and Francis, all the journals of very well repute. He has contributed chapters on different themes such as nanomaterial synthesis and their applications in energy conversion and storage devices, quantum dots, spectroscopy of lanthanides, and etc. He is an author of book titled Phosphor for Energy Saving and Conversion Technology, published in USA. He has edited a book titled Nanomaterials for Green Energy, spectroscopy of lanthanide doped oxide materials. So I welcome sir, Dr. Pavde, Vijay Pavde sir here. Please, you may start your conversation, please, sir. Hello.
Yes, sir. Hello. My sound is audible. Hello.
Yes, sir.
Anyone? Okay.
Yes,
Thank you,
please.
Chairman sir, for introducing me. And also thanks convener of this conference, Pawar sir, for inviting me to deliver a talk
technical talk on rare earth phosphor for enhancing photocatalytic activity. So let us start outline of the talk. This is the outline of my talk in which I would like to focus on phosphor, their photo emission excitation mechanism, type of phosphor host, type of rare earth element that we are used for doping, rare earth phosphor and their present applications, and scope of phosphor in environmental friendly technology and energy conversion devices. And side by side, we mainly focus on photocatalysis, that is use of phosphor, which used to enhance the photocatalytic activity of some kind of metal oxide materials, and some reported literature that based on application of phosphor. And most of the fundamental part has been covered by Professor Omanwar sir regarding luminescence mechanism, whatever. So mainly here I focus on application of phosphor in enhancing the photocatalytic activity of metal oxide semiconductor materials. Okay. So in introduction, I would like to focus why this topic is important to develop this environmental friendly technology. And we know that due to current situation of current globalization in industrial sector, day by day the demand of new and technological product is also increasing. So there is huge competition between industry to provide a product at lower cost. So demand of public in new and advanced technological product, and many industries work hard to provide and manufacture the product at lower cost. Okay, so due to this and demand of low cost product, they select raw materials that comes from the scrap. For example, we know well example of China. They are providing the product at 1 rupees also. For example, LED. Okay, that are possible only with the help of collecting the materials from scrap. So for these applications, for this purpose, they are collecting the scrap from outdated technological product, for example, electronic products, computer chip, whatever. They collect the raw materials by using their recycling plants, develop recycling plant to separate metals and many kind of raw products from the outdated technological device. So during this process, recycling process, many kind of harmful gases get liberated from this recycling plant, and as well as many kind of heavy elements get sprayed in fresh water. Okay, so they can show negative impact on the environment as well as in the human health. So to avoid this type of technical product, we need and such technology that can save our global environment as well as they can't affect on our health. So for this research organization and many kind of researchers are taking efforts on the development of new and advanced water purification technology to reduce the level of this pollutant to some extent. So as well as they are developing new and renewable energy sources, for example solar cell, and as well as they are focused on the development of hydrogen generations for the automobile sector. Okay, so to fulfill this demand, there is a need of new and advanced materials that can applicable for the hydrogen generations. That material also useful to remove harmful pollutant from wastewater. So water purification is an urgent need of current century to protect our fresh water resources as well as to protect the human health. Okay, so these are the current scenario, how China importing raw material from all over the world. Okay, and provide the new kind of product at lower cost, including example of LED, cell phone, computer chip, other spare part of electronic devices. Okay, and these are the contributions of each country. Okay, in of greenhouse gas emission, that is a major issue. And this is the current scenario of air pollution, how they affect by using our traditional energy generation plant, for example coal power plant. Okay. And other industrial plant, they are used on the basis of this coal heating whatever, so they can liberate many kind of harmful gases, nitrogen, sulfur, etc. They can harshly damage our ozone layers. Okay, so indirectly they can affect plant and the global planet. And these are the current scenario of water pollution, how industrial waste, they are continuously get spread, fresh water, river, pond, etc. And this is the current picture in India, everywhere in major cities like Nagpur, Amravati, whatever. So many fresh water pond also get affected by plastics and some kind of electronic equipment, waste product, etc. Okay. So this is also another example of soil pollution, how the industrial waste are continuously spreading in the fresh water. Also, they affect the soil. Okay. So these are the current picture and current scenario. That's why there is a need to focus on the development of environment-friendly technology to sustain our environment. And this is a very hot issue. Okay. So global action is very wide and very important focus of discussion today, and there is need to spend more time on research what it is and their effect on the global atmosphere. So scope of research and innovation in the environment related problem is very wide, and it deals with the many hot areas like conservation of natural resources. That's a big challenge of current century. Ecological aspect, pollution of the surrounding natural resources, controlling the pollutions, whatever air pollution, soil pollution, or water pollution, soil issue, also again social issue that are connected to it, and impact of this pollution on the global atmosphere. Okay. So in that manner, the material that used for this kind of technology, that used for water, wastewater treatment, that's also used for the hydrogen generation.
Sir, why? Sir, please. I think Dr. Pavade unmuted. I think so. Please, sir. What is the problem, please?
Hello. Yes.
Yes. It's okay now. It's okay.
So this is the simple absorption and emission mechanism that we can understand from this picture. Absorption, material can absorb light of one wavelength and they can emit light of other wavelength. This is simple excitation and emission mechanism. And there are some kind of some phosphorus, they are mostly used for variety of technologies. They can use for the optoelectronic devices, photovoltaic, magnetic, electrical, electrochemical, ferroelectric, superconducting, piezoelectric, and photocatalytic materials. And they consist of inorganic materials with a perovskite-like structure. Because this perovskite-like structure can be very interesting, they can show chemical and physical properties. So among this variety of host materials, aluminate, borate, tungstate, vanadate, silicate, phosphate, sulfate are the most used materials in lighting devices. Also, they can be used for this kind of applications like magnetic materials, optoelectronics, and photovoltaic technology. Okay, so for this to vary the properties like electrical and optical or magnetic properties of the materials, there is need of doping. So doping can affect the structure of materials. So with the help of this doping, we can modify the property that related with the materials. So there are variety of impurity elements. Among the 15 elements, some of the impurity are mostly used in the lighting devices, for example in LED and display devices, and some kind of impurity elements like holmium, neodymium, erbium, thallium, and Yb3+, they have the ability to emit the light in a near infrared region. So these kind of near infrared emitting elements are used for the solar cell applications. Okay, so based on this rare earth element, 15 element, we have categorized their oxidation state and corresponding emission bands. These are the different emission band for different elements. Europium in 2+ and 3+ state can show this red and blue emission band. Dysprosium, they can have also show this blue and red emission band. Yes, sir. Oh, 1 minute. 1 minute. So these are the different impurity element that used for the doping, and they have the ability to show a different emission and excitation band that listed here. Here europium in 2+ and 3+ state, they have the ability to show blue and red emission band. Also dysprosium, they have the ability to show this blue and yellow emission band. They are if they are excited by this corresponding wavelength regions. So I am not going in details, so let us focus on other part. Why these rare earth doped phosphor are so much important in viewpoint of this development of environment friendly technology? First of all, these rare earth doped phosphors are mostly useful for the development of LEDs and display devices. They have the potential energy source, okay, and they have the ability to save energy, as well as beside this phosphor rare earth doped phosphor can be used in light conversion efficiency and energy conversion devices like solar cell. Along with this, they have the application, they have the advantage to applicable in wastewater treatments. Okay, so based on this fundamental concept of phosphor and its working mechanism, so this rare earth activated phosphor can find a potential solution in the development of environment friendly technology, that is the need of current era. Okay, so first, these phosphors can have advantages. They are used for the LED devices. These are the well-known materials. These Y2O3 doped with the europium. This is red phosphor. Blue, yellow, and green phosphor. These are the basic fundamental phosphor that shown here. They can be used for the production of white light. That is white light emitting. Have the number of merits in saving energy, as well as they have long operation lifetime, and also they can show better stability as compared to other devices. Okay, so based on this energy saving potential, they are mostly used in everywhere. Okay, another phosphor type, upconversion phosphor. This upconversion phosphor is also an important phosphor material that show that first discovered reported by Dutch physicist Bloembergen.
Sir, Pavade sir, Pavade sir.
Audible.
Unmute yourself.
Unmute yourself, please.
Yes, sir. So therefore, this upconversion have the potential application in optoelectronics light. They are used in LED, solar cell, as well as they are used in sensors also. Okay, and this upconversion have two or more longer wavelength photons are first absorbed by the materials, that is phosphor material, when we dope with some kind of impurity elements. Okay, and later it emits a single or shorter wavelength photon. So this upconversion process required at least two metastable states for this purpose. So lanthanide is a better option to achieve this kind of upconversion process when it doped with phosphor host materials. Okay, so based on this, they are partially filled 4F inner shells, which is responsible for this optical process. Okay, and the electron in 4F orbit takes part in the process with the function of multiple energy states ranging from this near infrared region to ultraviolet range. Okay, and these are the well-known materials, that is such as oxide glass nanocrystals. Then it exhibits some emission with low phonon energy, and it reduces the non-radiative transition losses in conversion process. And now this subconversion emissions in lanthanide activators gain more importance because of its excellent performance, like plenty emitting colors, high color rendering index, that is CRI index, as well as they act as the efficient photocatalyst for harvesting, and they can use for the wastewater treatment. So now we see what they show when we couple with metal oxide semiconductor materials. What is the role of this upconversion phosphorus? Another kind, that is down conversion. This down conversion is also a process of photon conversion, and but the mechanism is different than that of the upconversion. So in case of down conversion process, high energy photon in the ultraviolet region or in visible spectral range is converted into two or more low energy photons, that is in the near infrared region. Okay, so this near infrared photon obtained from the spectral conversion, that is from down conversion mechanism, it creates electron and hole pair only, and hence it reduces the excess energy that generate in the form of heat radiations. And a well-known impurity element, that is Pr3+ state doped with fluoride host, can show this kind of down conversion mechanism. And lanthanides play an important role in the down conversion process due to their wide range of spectral energy level that provide more chances of efficient photon conversion. So photon conversion is an important mechanism for the photocatalysis process. Okay, so these are the well-known impurity atom Tb3+, Yb3+, Pr3+, that dope with Yb3+, holmium3+, that dope with Yb3+, erbium that dope with Yb3+, are the well-known combination of these rare earth impurity element that used in the down conversion materials, and also acts as a potential photocatalyst for the wastewater treatment. Okay, so scope of phosphors, they are used in environmental friendly technology, that is solid state lighting, because of these their energy saving potential, high quantum efficiency, high thermal stability, long operation lifetime, excellent energy saving and capabilities. So phosphor used in fabrication of this wide limiting diodes must have this meet this requirement. And these are the overall benefits of this lighting: energy benefits, environmental benefits, economic benefits. So how they get affect the environment? So because of the use of white light emitting diode, we can reduce the level of coal power plants. Okay, because traditional lighting utilize more power. So LED, naturally LED required less power. If you use LED lighting everywhere, then we can reduce the consumption of electricity to few extent, and indirectly we can reduce the number of power plants. So indirectly we can reduce the level of CO2 emission from this power plant, like sulfur, nitrogen, and CO2, etc. So this type of liberation of harmful gases can be reduced to some extent by using this solid state lighting source. Okay, and another, we focus on energy conversion devices. So energy conversion devices, here we focus on particularly up conversion and down conversion phosphor layer, how they are applicable in modifying the solar cell response, because in market there is no substitute for the silicon solar cell, because perovskite type solar cell came in existence, but they cannot be commercialized yet because the contamination of harmful toxic element like lead. Okay, so solar cell have the longer durability, and but they face the problem of conversion efficiency. Only 19% of efficiency they can achieve till date. But with the help of this kind of phosphor layer, up conversion and down conversion phosphor layer, they acts as a conversion phosphor materials. So they have the ability to convert photon conversion. So photon conversion is only a ideal way to enhance the conversion efficiency of solar cells. Okay, because silicon have the small ability to capture only few component of the solar radiations. Okay, it cannot capture the visible light. So to enhance the light capturing ability of the silicon solar cell, we have to spread such thin layer of phosphor materials that can convert this longer wavelength photon to shorter wavelength and shorter wavelength photon to longer wavelengths, so that they can enhance the light capturing ability of the silicon solar cell, so that they can generate more current. Okay, so these are the other advantages of this phosphor in energy conversion devices like solar cells. So how they are used in photocatalysis. So now we mainly focus on what are the purpose of phosphor material towards the development of environmental friendly technology to sustain our global atmosphere, to sustain our natural resources. Okay, so photocatalysis is a material that utilize sunlight energy to facilitate the chemical reactions. Okay, so there were photocatalysis as an economically cheap, simple, and environment-friendly technology that can be applied in wastewater treatments. Can be photocatalyst, can be applicable in solar cell, can be applicable in hydrogen generation, as well as they are used in organic photosynthesis. So these techniques are based on the sunlight radiation that is available everywhere. Okay, and there is no additional source or energy required to hold this type of photocatalytic process. Okay, so currently photocatalysis using solar energy is gain more importance. Okay, worldwide because of increasing environmental crises and energy related problems. So in past few years, semiconductor based photocatalyst has been proposed for the degradation of pollutant. So degradation of harmful pollutant in the wastewater that comes from the industrial waste. But this kind of semiconductor material have the narrow band gap, okay, but they have the less efficiency to capture the light in the visible spectral range. Okay, they have the ability to show ultraviolet band, and they contribute for the photocatalysis process. So to enhance the catalytic response of this type of semiconductor materials, researcher proposed
Sir, I think it is unmuted, please. Just look into the matter, please. Hello.
Pavade sir.
Dr. Pavade, please.
You are
You
audible.
might have been unmuted, please. Check it. Check it. Dr. Pavade, please. Hello. Hello, Dr. Pavade. Am I audible, please?
Yes, sir.
I think there is a problem in his network connection. I think so.
Yes, right, sir. Pavade sir. Hello.
Yes.
Pavade
Just wait for a while. Dr.
Yes,
Pawar sir, please call him.
Yes, right, sir.
I think he has unmuted by mistake. Hello, Pawar sir. Pawar sir. Hello.
Yes, sir.
Is there any problem? Continue.
Yes, sir. Connectivity problem. He will rejoin, sir. Yes.
Acha. That's all.
झालं ना शेवटचं आहे ना ते.
Sir, you can call him to message what is the problem. Then we can just take the decision. Okay.
Okay, sir. Connectivity issue. Okay, sir.
Please call him.
Yes, right, sir. Okay, sir. Sir, he will rejoin. Okay, sir.
Okay.
He will take 5 minutes, last 5 minutes. Okay, sir.
I think, sir. Hello. Hello.
Sir.
By considering time constraints, we can conclude now.
Okay, sir. Okay, sir.
Okay. So you just tell Dr. Pavde if you have conversation on mobile. Okay.
Yes, yes, right.
So he has nicely given this his demonstration. If any kind of queries are there, then please participant, please share your queries, because he is not there. If it is possible to answer me, then I can. Otherwise, we will conclude. Hello. Am I audible, sir? Please.
Yes, sir. Yes, sir. You are audible.
Dr. Vijay Pavde has cleared many concepts related to health and environment, and he also has shared worries due to globalization in industrial sector. His worries are also due to the huge raw materials provided by India to the other countries, and to get manufactured the tools or equipments at low cost to sell in India. Saving of global natural atmosphere in terms of ecological aspects is also important. He also focused on rare earth doped phosphor as an environment friendly materials to help to save global environment. His special energy conversion devices are also important. I think I thank him on behalf of Raman 2021 and conclude the session. Okay. Thank you very much. Dr. Pawar.
Yes, sir. Thank you, sir.
Please.
Okay,
comment.
sir. Okay, sir. Thank you, sir. Dr. Kohole, Ritesh Kohole. Okay, sir. Thank you for the nice handling of this technical session, sir. Okay, sir. And thank you, sir. On behalf of Raman 2021. Thank you, sir. Bye, sir. Good day, sir. Now for the technique, we'll start a technical session 2. In technical session 2, we have shared the 2 links. OP from 1 to 25 will remain in the same meeting, and OP from 27 to 51, please join the Raman classroom. That has been shared in your WhatsApp group and also on your email. Bijwe sir. Hello. Bijwe sir. Dr. Bijwe sir.
Okay. Yes, sir. Yes, sir.
Yes, sir. Please handle this session, sir. Okay.
Okay. Thank you, sir. May I audible, sir?
Yes, right, sir.
Okay. Thank you, Dr. N.R. Pawar, who is the convener of the nicely organized this international conference, Raman 2020. Very good afternoon to one and all. Now, myself, Dr. Dhananjay R. Bijwe, Assistant Professor, Department of Physics, GS Tompe, Art, Commerce and Science College, Chandrabadar. Now, it is time to shift towards the next technical session, that is the technical session 2. Is the technical session 2 part 1. In this session, we organize the 25th oral presentation, that is OP1 to OP26. Now, dear participants, respected guests, faculty and students, I welcome you all in the second technical session of International E-Conference on Recent Advance in Material Science and Nanotechnology, Raman 2020. Am I audible, sir? Hello?
Yes, sir. Audible, sir. Yeah.
Okay. Now, the chairperson of this session is Dr. V.D. Kapse sir. I request to Dr. Kapse sir. I welcome to Dr. Kapse sir with memento. Virtually welcome to Dr. Kapse sir. Please, Dr. Kapse sir.
Yes, thank you, sir. Thank you very much.
Virtually welcome.
Thank you.
In second technical session in Raman 2020. Firstly, I introduce the today's chairperson, Dr. Kapse sir. He is the head of Department of Physics, Arts, Science and Commerce College, Chikaldara, and he has 64 research publication in the international journals. He has 8 H index and 10 I-10 index. He has 8 invited lectures and chairpersons. He had 60 research paper presented in the conferences, seminars. Now, one minor research will be completed. Now, here, under the guidance of Dr. Kapse sir, 3 students will be awarded the PhD, pursue the PhD degree. Now, completed one major project. He is working of reviewer of the different elsewhere journals, and also he is a member of the board of studies in the subject of physics HGPU Amravati. Now I welcome him in this virtual session on behalf of organizer. In this technical session, there will be oral presentation of OP1 to OP26. I would like to request all of you, please be ready for your turn. I request all other participants, please keep your mic mute when the participant presenting his oral presentation. Again, I request to Dr. Kapse sir, you may start the session.
Thank you. Thank you very much, Dr. Bijwe sir, for your kind word of introduction, of my introduction. Thank you, Dr. N.R. Pawar sir. First of all, I would like to take this opportunity to say namaste to my guru, Professor, respected Professor Dr. Omanwar sir, Professor Chimankar, Professor Dobde, and convener of this international e-conference, and my friend Dr. N.R. Pawar, conference delegates, research students. Very good afternoon to one and all. Now, as per the schedule of day 1, now we are about to start the second technical session on day 1 of this international e-conference organized by the Department of Physics, Arts, Commerce and Science College, Maregaon, and Department of Physics, PN College, Pusat. First of all, I would like to mention here that I am very pleased and honored to be invited as a chairman for this technical session. And as rightly pointed out by the convener of this international e-conference, that in this technical session, about 26 research paper numbered as OP1 to OP26 will be presented by the researchers. And due to some technical reasons, I would like to mention that OP6, 7, 19, 20 will not be considered for presentation in this technical session. So with this note, I would like to mention here that for each presentation, there will be given a time slot of 7 minutes for presentation and additional 1 or 2 minutes for a discussion, or you can say the question answer session. Remember one thing, because we are already late by 1 hour and 10 minutes. So as whatever may be the time that has been allotted to each presenter, he should stick to that allotted time so that everyone can get a fair chance to present his or her research work. So with this note, and also I would like to mention here that convener has recently shared one message on Raman 2021 WhatsApp group that presenting authors will be called for presentation, and rather reading the titles of their paper, they will be called by announcing the paper number or abstract number mentioned in the schedule of day 1. For example, suppose I am saying that please the author of OP1, that means the abstract number or paper number 1, and he has to join and start his presentation. So without wasting much more time, I would like to invite the present author of OP1 to present his research paper. Hello. Hello.
Yes, yes, yes.
So I have just mentioned that paper number 1 and the name of presenting author is R.L. Kohde. I would like to request R.L. Kohde to start his presentation. I think he is not there. So without wasting much more time, I would like to invite second paper presenter, Mr. A.P. Pachkaude. A.P. Pachkaude, please. And I would like to request the organizing team, if any presentation, any author, or you can say any research student starts his presentation, organizer has to make him as a co-host because he has to share the screen for PPT presentation. I think Pachkaude is nowhere, is also absent. Then I would like to announce the third name, A.Y. Sheikh, OP3. Dr. N.R. Pawar, sir, I would like to have a word with you.
Hello, sir.
What to do? Most of the students or research students are absent. I would like to say that if any one of the research student having the paper number from OP1 to OP26, if he is present, can he unmute himself? Is such arrangement is provided?
Yes, yes, sir. 1 minute, sir. 1 minute, sir.
Yes, yes, please. So if any one of the students or researcher having the paper number OP1 to OP26 is present in this Zoom meeting, rather than reading the names of all the research students or researcher who is going to present the paper, I would like to request those who are present in this conference meeting having the paper number OP1 to OP26, please come forward if you would like to.
Patil, sir.
Good afternoon, sir.
Yes.
Good afternoon, sir.
Yes, sir. What is your name, please?
Sir, my name is Sachin Rai.
And paper number, please.
Paper number 12.
Yeah, you may proceed, sir, please. Please start your presentation.
Okay, sir.
Sir, please make him a co-host so that he can share the PPT.
Okay, sir.
उद्या आमच्या विद्यार्थ्यांचा 4 विद्यार्थी उद्या तयारी घेणं चालू आहे त्यांची. आता उद्या कॉलेजमध्ये त्यांचं होतं.
I would like to request participants, other participants or delegates or respected teachers, please unmute yourself. Sorry, please mute yourself.
Personal voice is coming, sir, please.
Yes, yes, yes. Who is going to present? OP12?
Ji, sir.
Sachin.
Please allow him me. Sir, please allow him me.
Yes, 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 Sachin Rai. I think the convener of this conference is trying to make you a co-host. And after this, it will be possible for you to share the screen.
Yes, sir.
Yes, please wait.
Okay, sir.
Thank you.
Okay, sir.
Second one.
Pawar sir.
हाँ सर.
Pawar sir, please make Sachin Rai as a co-host. Sachin
Yes, sir.
Rai.
तो नहीं होगा तो उसी से कर लेना, ठीक है? अपना तुम्हारा नाम सब ले जाएंगे।
Okay, sir.
Yes, sir. Sachin Rai, please. Now you can share the screen and start your presentation. And I request all other delegates and participants to please mute your microphones. Thank you.
Excuse me, sir.
Yes.
Sir, myself Priyanka Priyadashini Singh. I am OP 80.
Yeah. After presentation of OP 12, you will be allowed.
Okay, sir. Thank you, sir.
Thank you. Sachin Rai, please start your presentation. Sachin Rai, can you hear me?
Kapsil sir, you take Priyanka is ready.
You are not
We
audible.
do.
Kapsil sir.
Yes,
Dr.
yes.
Kapsil,
Yes, please.
you may take next participant.
Okay.
I think Priyanka is ready. Priyanka is
Because
ready.
every time the technical support team has to make the presenting
Yeah.
author as a co-host, please.
Yeah.
I would
Yes,
like
sir.
to request
Yes,
OP
yes.
18 presenting author of OP 18.
Sir.
Yes.
Yes.
Are you
Sir,
ready?
myself is OP 8, sir.
OP 8, please, you may continue.
Okay,
What is
sir.
your name?
Sir, my name is Priyanka Priyadashini Singh.
Okay. So I request technical support team to make
Yes, sir.
Priyadashini
Yes,
Singh
sir.
as a co-host.
Yes, yes, right, sir. Priyanka ma'am, start your video. You are co-host. Yes, right.
Now you can share.
Okay. Yes. She is visible.
Please start your presentation.
Good afternoon, everyone. Myself Priyanka Priyadashini Singh from Veera Surendra Sai University of Technology, Borla. And today my topic of discussion is smart sound absorbing material for environmental noise reduction. This is the outline of my presentation. Please have a look upon it. And this is the graphical abstract which I am going to say in details in my further slides. Mainly the acoustic materials are made up of either synthetic fiber or natural fiber, but as I am taking the natural fiber, so these are some of the disadvantages of the synthetic acoustic material. They are difficult to manufacture as the precision manufacturing is required. Cost is the major factor. Difficulty in manufacturing high temperature material. Knowledge about the material is not widespread, and once it is damaged it cannot be repaired, and the whole metal has to be replaced by the new one. And this is as I am taking organic waste material, and I am taking here Lupha cylindrica as my organic waste material, and because it has a novel fibrous networking structure as well as its composition, so the worldwide production of Lupha cylindrica fiber is annually 42% more in compared to the other organic waste, and these are the composition of the Lupha cylindrica. And my main motive is to modify the agricultural waste product into the activated carbon form to absorb more sound. And this is about Lupha cylindrica. This is the graph showing annually production of Lupha cylindrica in different countries of the world. And here this is the cut. It is a cut portion of a Lupha cylindrica fiber. And here you can see this is the inner layer, this is the inner layer, and this is the outer layer, from which we can see that it has a unique fibrous networking structure, which makes it a unique fiber material from all other fibrous material. And this is the physical property of Lupha. And my main objective of the work is to convert this Lupha cylindrica waste material into the green acoustic material, so that it can be used as a sound reflector, sound barrier, sound diffuser, or sound absorber. And now coming to the part what is biocomposite and how Lupha fiber can be treated as a biocomposite. The biocomposite is a composite material formed by the matrix and reinforcement of natural fiber or waste of organic products. Here, Lupha fiber is the waste of organic product I have taken, and when it is blended with epoxy and hardener, and we find the Lupha fiber biocomposite. And these are the mathematical formula I used during my whole work. And this is the material and methodology, and this is the whole process of preparation of binary mixture of tartaric acid and different alcohols like methanol, ethanol, butanol, and propanol using ultrasonic technique. And these are the whole method and process from collection of Lupha fiber to the sample preparation. Please have a look upon the whole process. And this is my final sample prepared. I have taken 4 layers of Lupha fiber to make my biocomposite. And this is the arrangement, experimental arrangement, which is done in our own laboratory for the sample preparation. And now coming to the part of the SEM and EDX characterization of Lupha fiber composite. Here you can see this is the SEM of Lupha untreated, where the fibers are distinctly seen and it has more impurities in it. And this is the SEM of Lupha treated. After the treatment of blended solution, this fiber surface becomes rough. And this is the SEM of Lupha composite, where you can see many porous structures are present on the surface of Lupha composite. And this is the energy dispersive spectrum of the Lupha fiber, where the key elements are carbon, oxygen, and silicon, which are mainly needed in my work. So here carbon stands for high absorption, oxygen stands for light weight of the material, and silicon stands for the high mechanical strength of the material. And now coming to the part of the result and discussion. Here it is the graph showing the sound intensity with time for a fixed frequency with time with sound intensity. Here the red dots represent the sound intensity with material, and the black dot represents the sound intensity without material. Now coming to this graph, this is the graph showing sound intensity with time for various frequency. And from this graph we can conclude that the intensity of sound energy decreases about 18 decibel with presence of material in compared to the absence of material. And this is the graph showing absorption coefficient in audible frequency range, where you can see as I have taken 4-layered Lupha, so highest sound absorption coefficient is seen in the 4th layered Lupha, and the optimum value of sound absorption coefficient is 0.877 at 6000 hertz. This is the graph for thermal conductivity of the Lupha. As you can see, with increase in weight percentage of Lupha fiber, the thermal conductivity starts decreasing, from which we can conclude that my material is thermally insulated. And this is the electrical conductivity of the Lupha fiber composite, where you can see that with increasing weight percentage of Lupha fiber, the electrical conductivity rises to the power 10 to the order 10 to the power minus 3, which is very small. And from this we can conclude that my material is electrically insulated. And this is the hardness test of the Lupha fiber done in 253 millimeter square area of the Lupha fiber surface. And we can see here, with increasing in load on that surface, the hardness of the material increases to a certain point, and then it gets saturated. So this is in a laboratory scale, and if you are preparing in industrial scale, so its mechanical strength will increase. and this is the basic mechanism of sound absorption, where this is my loofah fiber sound absorber, where you can see when sound is incident on my loofah fiber sound absorber, due to its novel internal structure, novel fibrous networking structure, the sound gets absorbed into the loofah fiber, and some amount of sound is transmitted outside, which is of low intensity. And these are the main consequences of sound absorption. They include thermal loss, mechanical loss to the skeleton, heat conduction, and momentum loss. These are the conclusions drawn from the structure. The composition of loofah fiber can be used as best material for synthesis of acoustic material. Chemical treatment can increase the interface
मुझे तो
of
पूरा रीड कर रही है, मुझे
epoxy
पीपीटी
matrix.
अच्छी बनानी पड़ेंगे है ना।
Composite
एक तो
can be
देखिए कि कैसा दे रहे हैं प्रेजेंटेशन।
insulator. The synthesized material is class B type sound absorbing material with absorbing coefficient of 0.877. It has potential for the reduction of environmental noise pollution, and mainly the four-layered loofah fiber composite is mainly to be more potential than the single-layer loofah fiber composite. These are the references. And lastly, I want to acknowledge Planning and Convergence Department, Government of Odisha, and Veera Surendra Sai University of Technology, Burla. Thank you.
Okay. Now I request all the participants, or you can say I invite all the participants or delegates to have an interaction with the presenting author. You may ask any question, or if you have any query, please share with the presenting author. Session is open for discussion. Anyone? I would like to ask the presenting author how your results are better than the earlier published results. In what way your results are better?
Yes, sir. Sir, I have taken this loofah. Sir, I have taken this loofah fiber because due to it has a novel networking fibrous networking structure, so that it can act as a good sound absorber. It best sound absorber in compared to other sound absorbing due to its peculiar type of networking structure, sir.
You have mentioned in the preparations section or synthesis section that you have made the use of different types of alcohols.
Yes, sir.
For what
Sir,
purpose different types of alcohols?
Sir, I have taken methanol, ethanol, butanol, and propanol, sir.
Okay, in combination.
Yes, sir. In weight percentages, sir. Different weight percentages with tartaric acid.
Okay, okay, okay. Thank you, Priyadarshini Singh.
Thank you,
for
sir.
nice presentation.
Thank you, sir.
Now, I would like to invite the next presenting author, and I would like to request, please come forward and tell us who is going to present so that we can make him a co-host.
Sir, excuse me.
Yes, sir, please.
Miss Bharti Patil will be interested to present the presentation.
Bharti Patil.
Yes, yes.
So
Bharti
please,
Patil.
so Bharti Patil, please make her a co-host. Bharti Patil. Bharti Patil, ma'am, OP
Screen.
paper number?
OP 21, sir. OP 21.
Okay, okay. Thank you. You are co-host now. Please start your presentation.
Okay, sir. Good afternoon to all of you. Myself, Dr. Bharti Patil, working as an assistant professor in Maharaji Vajjoshi College, Srigoda, Ahmednagar. First of all, I am very much grateful to the organizing committee of Raman 2021 for giving me an opportunity to present my work in front of you. Topic of my presentation is structural and morphological characterization of NiCO SGC nanopowder synthesized by glycinated combustion synthesis for its application in intermediate temperature solid oxide fuel cell. Here is one solid oxide fuel cell shown. Solid oxide fuel cell is a fuel cell which consists of anode, cathode, and electrolyte is sandwiched in between them. At anode, we are supplying the fuel such as hydrogen, and at cathode, we are supplying the oxidants such as air from the nature or oxygen. This is the chemical reaction which takes place inside the SOFC, and it gives water and along with the generation of electricity. But problem with SOFC is that its operating temperature is very high, about 1500 degrees Celsius, and hence there is a material constraint. Therefore, the commercialization of SOFC is a problem. Therefore, in order to commercialize this technology, there is necessity to reduce the operating temperature of SOFC to the point where less expensive materials can be used for its fabrication. That is, it comes into the intermediate temperature range, that is in between 600 to 800 degrees Celsius. And hence, my research work is related to fabricate such anode materials which will operate in this temperature range. Nickel samarium doped ceria is proven as a best anode material for SOFC. But when we use the anode materials, it should fulfill the characteristics such as it should be a good conductor, it should be a porous in nature in order to increase the electrochemical surface area, it should be highly porous in order to increase the catalytic reactions, and it should not get corrode when it comes in contact with the electrolyte. There are two possibilities of it, either to use metal based conductor, but in case of SOFC, three-phase boundary concept, that is the region where oxygen ions from the electrolyte, then fuel and the catalyst meet. That area is called as three-phase boundary region, which will decide the performance of the fuel cell, and it will get restricted to only the interface between electrode and the electrolyte, and hence the performance of the fuel cell get decreased. But if we prefer mixed ionic electronic conductors such as nickel yttria stabilized zirconia or nickel samarium doped ceria, then performance of fuel cell get increased because the whole anode material will act as a center for the catalytic reaction, and hence I have chosen such type of NIO SDC based anodes materials for my research work. It has been observed that there are certain problems related to NI based anodes because at higher temperature of about 1100 or 1200, there is a segregation of the nickel particles, and because of that, the performance of NI performance of fuel cell get reduced. Also, there is formation of carbon when we use these anodes in case of HC, that is hydrocarbon based fuels, and hence in order to modify this nickel based anode materials, there is necessity to reduce the quantity of nickel and introduce certain elements such as molybdenum, then cobalt, copper, and such type of elements have been doped in case of NiCO, NiSDC materials. And it has been seen that the properties of the anode materials will be enhanced by the doping of such type of materials in the life of anode. And recently it has been reported that when we take the composition of the nickel at 0.25, cobalt at 0.7 SC material, then performance of fuel cell is proven as a good. And hence in my research work, I have chosen this material anode for the fuel cell fabrication, which will be operate in intermediate temperature range. And also SDC material will act as a support for the nickel particles, and it will give the ionic conductivity also, and hence these materials are called as ceramic materials, or these are called as composite materials, because we are going to form the separate phases related to Ni and SDC. So reports are based on the reports. This material is earlierly deposited by the sol gel method, then spray pyrolysis method, and hydrothermal method. In my work, I have chosen glycine nitrate combustion synthesis for its fabrication, because in case of glycine nitrate combustion synthesis, I have chosen glycine as a fuel because this react non-violently, and also it is non-toxic. And in this method, you have to mix the various nitrates corresponding to nickel, cobalt, cerium, and samarium in the ratio of stoichiometric ratio. Here I have chosen nickel S2 SDC ratio as 7:3 and nickel CO as 0.25 to 0.75. I have to mix them in a double distilled water, mix thoroughly and form a homogeneous mixture. And after that, I have to heat this solution on a hot plate with constant stirring at 80 degrees Celsius. I will found a purple color gel. After that, I have to increase the temperature of the hot plate to 220 degrees Celsius. And at this temperature, a combustion reactions takes place, which is self-sustained, and it will remain for fraction of seconds, and a large amount of gases such as N2, H2 and CO2 will get evolved. And the gases which are evolved are not that much hazardous to the environment like carbon monoxide and NOx, and hence this method is said to be environmental friendly method. After that, we will obtain the powder having coffee brown color, and after that we have to heat it at 600 degrees Celsius for further crystallization. And in this way, within a fraction of time, one can generate nano crystalline desired powder. I have characterized this powder by various characterization techniques. I have completed only three techniques characterization, that is XRD, SCM and ADAX. One by one I will discuss it. I have taken the powder which is as synthesized and the powder which is heat treated at 600 degrees Celsius. It is seen from the XRD pattern of both the powders that the powders are having well crystalline nature. They are polycrystalline in nature. All the phases have been identified and indexed with the known patterns of the SDC, NiOCO and CO3O4. It has been observed that in case of as synthesized films, I have obtained the peaks corresponding to SDC, NiO and COO. But in case of powder which is heat treated at 600 degrees Celsius, I have obtained the peaks corresponding to SDC, that is samarium doped ceria, NiO, that is nickel oxide, and CO3O4. It means that I had at higher temperatures, COO phase get converted into CO3O4, and reports are also in the similar manner that in between 600 to 700 degrees Celsius, COO get converted into CO3O4. Thus, we have obtained the composite powder of NiO SDC CO or NiO SDC CO3O4 with the help of glycine nitrate combustion synthesis. So we have successfully synthesized this powder by glycine nitrate combustion synthesis. In both the powders, peak corresponding to peak 111 corresponding to SDC fuel is most intense. It has been further analyzed with the help of Sharal's formula, and grain size was calculated, and the grain size are found to be, these are the peaks corresponding to nickel phase 111, then SDC phase 111, 002, 022 and 113, and cobalt oxide phases are 111, 200, 220. It is related to as synthesized, and these are the peaks corresponding to the powder which is heat treated at 600 degrees Celsius for 2 hours. And these are the crystallite size which have been calculated by using Sharal's formula, that is 0.9 lambda upon beta cos theta. And it has been found that in case of as synthesized powder, the crystallite size is found to be 4.7 nanometer. And in case of powder heat treated at 600 degrees Celsius for 2 hours, the crystallite size is found to be increased. And this is due to the increase in the particle size of the material. Then the porous nature of the anode material is highly beneficial to increase the catalytic activity. Therefore, microstructure of the powder synthesized was analyzed with the help of scanning electron microscope. It has been observed that powder which is synthesized by glycine nitrate combustion synthesis with the ratio, that is 0.97, is highly porous, and it consists of good quality. And also, it is reported that when we obtain such type of porous nature, then automatically it will restrict further grain growth due to evaporation of the gases during glycine nitrate combustion synthesis. So highly porous powder have been obtained by glycine nitrate combustion synthesis, one of the most important requirement for the anode. Then the elemental composition of the powder, synthesized powder, was studied with the help of energy dispersive X-ray analysis. It has been seen from the due to connectivity. 1 minute, please. शेअर कर परत एकदा. Hello. 1 minute. There is discontinuity.
Okay. Please take your own time.
1 minute, please.
Okay.
Okay. Thank you, sir. I have speed up my speed in order to cope up with the time, but unfortunately, it has taken some time. So, index pattern shows that there are elemental peaks corresponding to nickel, cobalt, SM, that is samarium and cerium. No, our composite material consists of NiO, then CuO, and STC, that is samarium doped ceria, and the peaks correspond.
Yes, Patil ma'am.
1 minute, sir. Please, here is connectivity problem.
Okay.
I will finish within a few seconds.
Yes.
So it consists of the peaks corresponding to desired phases only. No other impurity peaks have been observed. There is only peak corresponding to a carbon element is observed, but it is due to the carbon strip that we are using during the sample preparation for SCM. So phase pure material has been synthesized with the present method. So I can conclude that with the help of glycine nitrate combustion synthesis, I have synthesized the desired powder, that is Ni 0.25, CO 0.75, SGC in nanocrystalline form. Its crystallite size ranges in between 4.5 nanometer to 7 nanometer. Then this nanocrystalline nature is going to help me in order to fabricate the anode, which will perform better in case of intermediate temperature range. Also, it has been seen that the powder is highly porous. It will going to increase the three-phase boundary region, and also its nanocrystallinity is going to reduce the sintering temperature which is required. And so these are the basic requirements for a fuel cell anodes. And in future, I am going to take its BET, that is brunette emitter surface area, because it is responsible for the electrochemical study of the powder, and hence in future I am going to take it, and I have to study its resistivity studies or conductivity studies also. So with this, I can conclude that I have successfully synthesized this material by glycine nitrate combustion synthesis, because very few or nominal 1 or 2 references are available only on the synthesis of material by glycine nitrate combustion synthesis. And I am proud to say that we are among few to deposit this material by GNP. So I have to acknowledge Ministry of New and Renewable Energy for providing us funds, then IIT Delhi for providing us characterization facilities, and the cooperation extended by Ms. Siddhi Mulik is highly acknowledged. These are few of the references that I have used during my research work. And thank you very much. If anyone is having any query, please ask. Thank you.
Very nice presentation, B. Patil.
Thank you, sir. Thank you, sir. Thank you.
I'd like to request the delegates or
Thank you, sir.
participants to have an interaction with B. Patil for any kind of query.
Yes.
Madam, in the experimental section, you have mentioned the nickel segregation has reduced. What affects the nickel segregation?
Sir, in case of SOFC, I have shown here one slide, but due to lack of time, I have not given that much time to explain it. Because in case of solid oxide fuel cell, the region where the oxygen ions from the electrolyte, here I have shown YZ, I have used here SDC, samarium dope ceria, the oxygen ion conducting fuel cell I am working with. So oxygen ions are coming, then fuel we are supplying, that is hydrogen, and the catalyst is nothing but the nickel. But that nickel at higher temperature get coagulated. Their particles will come together. Therefore, its dispersiveness will get reduced. So, in SOFC, in order to act, the mixed ionic electronic conductor should be such that the dispersiveness of the nickel throughout the material is required. And hence, in order to disperse it, it should be in nanocrystalline form. And we are using a backbone as a SDC because these nickel particles will get separated from each other with the help of SDC, which is an ionic conductor. It is going to help anode also, because anode is going to become both ionically as well as electronically conducting. And it is one of the requirement of fuel cell anode. If it is such that, because if we use only nickel, then three-phase boundary region I have shown in figure A, that three-phase boundary region will only restrict itself to that boundary between E conductor and YZ. But if I if I select such type of chemistry, then the whole anode surface is going to become a region for the catalytic action. And hence there is reported that the performance of the fuel cell will definitely increase if we preferred a mixed ionic conductor over a only electronic conductor.
Thank you.
Thank you
Thank
very
you,
much.
B.
Sir.
Patil, ma'am.
Thank you,
Now-
sir. Thank you, sir.
Yes. Now, I would like to request the next presenting author. Please come forward.
Dr. Kapse, sir?
Yes, sir, please.
Yeah, I am Dr. Gautam Singh from MIT University, Noida.
Yeah, sir, please.
Actually, I hope you remember me. We had a discussion while this Kalam series was going on in this institution, right?
Yes.
So if you to permit me, I can present my talk.
Yeah, please, sir.
Okay, thank you, sir. Thank you so much.
Gautam Singh, sir.
So please, Pawar sir, can you please make me co-host?
Yes, sir. Now you are co-host, sir.
Okay, thank you so much.
Pawade, sir. Sorry. Respected Kapse, sir.
Yes, sir.
Please intimate to participants, rename his name as his OP number.
Yes. I would like to request all the presenting authors, those who are interested to present their work, I would like to request them to rename their name as their paper number name. Paper numbers. Just like, for example, I am Dr. V.D. Kapse, then I will rename my name as OP6, suppose you are 7 or 8, whatever maybe your paper number is, so that we can easily identify the presenting author rather than searching the names. So please do this in a minute, and I would like to request Honorable respected Dr. Gautam Singh sir to present his work.
Thank you, sir, Kapse sir. It's
Yes,
nice
please.
meeting you again after a
Yes,
while.
sir.
Okay, so good afternoon to all. First of all, I would like to thank the convener, Dr. Pawar sir, and the chairperson, Dr. Kapse sir. I would really very thankful to you both, sir, because I am meeting you again on the virtual platform, because I had a meeting with you and other person during the Kalam series as well. So today I prepared a talk on the topic. This is the oblique chiral pneumatic phase in the hybrid bent core rod trimer mesogens. So it's again on the topic of liquid crystals, but in this time I will be sharing the recent results that we had on this new series of compounds. It's basically a new pneumatic phase that was discovered about 10 years ago, but still it's stimulated the entire research community of liquid crystal in the entire world, hoping that this could be the best nematic phase ever, because it will have the possibility to show the switching phenomena in the very at least in the microsecond region. I mean, that is maybe 1,000 times faster than what the regular pneumatic liquid crystal does, and that's what we have seen, or we are seeing in the display devices made of the pneumatic liquid crystal so far. So, but there are certain limitations as well on, because this has a certain limitations. So I will be dealing with that. But just to begin with, formally for the students as well, the pneumatic, basically this is a liquid crystalline phase, which is simplest phase ever. Which to be putting in the simple manner, that if you have a simple phase where all the molecules tend to align along one direction, that is called director, and ensuring that there is no ordering in the position, but of course we do have the long range ordering in the orientation. So due to the lack of the positional ordering, the molecules can slide, can move, float around in the sample, but at the same time they maintain the ordering in the certain direction. And because this is a fluid and the orientation, so this gives us a choice, provide a choice that we can change the direction of the director with a very small field. It could be electric field, it could be magnetic field, like that. So we can change and we can switch the the sample, and we can make a very faster switchable devices, including display and other devices as well. Now, what is the objective of having this kind of compound here? Basically, the reason is that the discovery of this new pneumatic phase was actually made on the bent core type molecule long back. But somehow, when this was verified experimentally, this was done on the dimer molecule. It was like rod-like molecules which we have, but if you have two molecules, connect them together with the flexible spacers in between these two, then what happens? Then that becomes a dimer. So the discovery was was confirmed experimentally in the dimer. But on the contrary, the theoretical decision was done on the bent core mesogens. So what actually we had done, we had taken that concept and we thought, okay, why not to try preparing this bent core mesogens and having and look for whether can we find out this new pneumatic phase. Okay, so this is called, so what we are saying, this is called hybrid. So bent core rod trimer. That means what we are talking, we take this is kind of something like something which we have like these two molecules, we can club them together. It's a bent core, and then sidewise you can attach the molecules and so on and so forth. So that is called the bent core trimer mesogens. So because this is totally about the this new pneumatic, this is called the oblique chiral pneumatic, or we can say the twist bend pneumatic phase. So there's a word pneumatic, but then again we say twist and bend. So before I go on to that, to define that, let me define you first for beginning that what is the pneumatic, and then the cholesteric, and then the twist bend pneumatic. So if we can see on this slide, on the left side we have a schematic diagram for the pneumatic phase, where we can see that all the molecules which have rods like spherical shaped molecules, they tend to orient along the certain direction. This is called the director N. This is a pneumatic phase. But if you add on some chirality, some chiral carbon chirality into the sample, or while making the compound, if you add the chirality in that structure, this becomes chiral pneumatic. This is called cholesteric. So what will happen? Because of the chirality present in the system, your director, which was uniform, it starts helical. It will arrange in a helical fashion, but ensuring that all the time, wherever you are in the sample, your director will be making 90-degree angle with respect to the certain. This is called the helical axis. So this is called the cholesteric liquid crystal, or we can say chiral pneumatic. So definitely here we have the chirality present in the system. So the chirality is inducing this twist in the system and becomes cholesteric liquid crystal. Now, when we come to this twist bend pneumatic phase, I would like to highlight and mention carefully that in this case, we do not require to have any kind of chirality that should be present in the system. Okay, so this is going to be achiral, non-chiral molecule, but the way they arrange themselves in the phase, that is going to induce this twist and bend and then pneumatic phase. So what happens, because this is, I said the oblique, and then I said chiral pneumatic phase. That means what is the difference between now the cholesteric and this one? That now your director, which was making 90-degree angle with respect to helical axis, now it's making some angle theta. This is called the tilt angle. So then it is going to be, so here what we have, this is called the director, we can see in this line N, and this is capital N italic, this is called the helical axis. So now you can see it, it shows that now your molecular director is going to proceed along the some hypothetical cone. So now the molecules are sliding in the cone like that. We can have the switching on the cone. So it's more easier when you have this kind of. This is called the twist bend image. So the twist and the bend. So there is a twisting because of that one, and then bend is this bend basically is something, a deformation which is coming because of the bent core shape of the molecule. Now coming to the main theme that I said, so what we are looking for here, that we try to find out, is there any possibility to see this new nematic phase that is called the oblique chiral nematic phase is present in the bent core mesogels. So can you, if you see on the slide here that I have shown, there are three different chemical structures shown on here. So the first one on the top, it says trimer 1. What we can see here that in this part, basically in the middle of that, this is the bent core compound. And then on the right side, you can see there is another rod. There are two benzene ring with cyanides. This is called the, it's more like a rod-like molecule. And this is attached with the bent core by some linkage group here. So can you see, we can see that the same group has been attached on the left and right side of the bent core molecule. Now that's why we're calling it hybrid, the bent core rod trimer. So rod and the bent core and then rod. So it becomes trimer molecule. Okay, so now we want to see what happens because of this bent core. Second, when you go to trimer 2, the only thing that we have changed here, that in the bent core mesoscale on the central benzene ring, at the ortho position, we can replace the hydrogen by the chlorine and by the methylene. I would like to see what happens to the phase structure or the phases present in the unsubstituted molecule, that is trimer number 1. So very interestingly, when we performed the experiment for the first time with the help of the high resolution optical project microscope, what we have done basically, we simply took this trimer 1 sample on the glass side and covered with the cover slip and kept in the hot stage and start heating the sample, and we melted it into the liquid phase and then start cooling from there and look at the optical texture. So what we found that as the sample cools down from isotropic liquid and goes to the nematic phase, so that what happens suddenly, this droplets starts forming. This is called the droplets, which scatter the light. These are called the nematic droplets. And then as the temperature goes down, these droplets will coalesce together and try to form some sort of texture. And so you can see that as we go down in the temperature, we really get the texture which are more like very muddy texture, some sort of marble texture, which is kind of the appearance for the nematic phase. But then as we keep cooling down, suddenly, like when we reach around 100, or I could say around approximately 80 degrees centigrade temperature, where suddenly what we found that on the sample under microscope, what we see is some sort of helical striations start forming. So that was the point where we were excited. Oh, we got something, because the presence of this kind of helical structure, or we can say rope-like texture, that has been set as a hallmark to identify the twist bend nematic phase in this type of compound. Now, after it, so this shows that the sample has been transformed from the regular nematic phase to a new nematic phase. This is called the twist bend nematic phase. And as we cool down further, what we see, until even at room temperature, this phase remains present. So this was something very exciting. So we wanted to confirm whether we are really talking about the twist bend nematic phase or this is something different. So to confirm that, what actually we did, we tried to prepare some sample cell with the certain kind of alignment layer. So first of all, we tried having this is called the homogeneous anchoring. That means we wanted to align the director along the along the plane of the substrate. So we have coated that and prepared the sample cells with the homogeneous anchoring alignment layer, and thickness was around 9.1 micrometer. And we kept the sample under microscope and tried to see how the texture looks like. So as we have intended to align the sample homogeneously, basically, then what happens, we would expect that I should have a very well aligned planar sample cell. But what we find that definitely it was trying to align it homogeneously. But what happens basically, because of there was certain alignment problem, then it was not, so we could see there are certain threads are coming still there. So it was not aligned 100% perfectly homogeneous. However, as we again reach close to the 90 and again to 80, suddenly the texture appearance changed. And we found that again, we are going to have the stripe-like textures present under the below 80 centigrade temperature. So this was again a kind of confirmation for this new nematic phase in our this compound. Again, we went on and changed the alignment layer and try to coat the sample, this substrate with the homotropic alignment layer and assemble the sample cell. And when we fill the sample and try to look at the under microscope, what we see that definitely we try to align it homotropically, but it didn't align that way. And it was a mixture of something like some many plane domains and align different directions. But however, as we cool it down further, so again when we reach to the below 80 temperature, what happens again, we see some certain types of hysteresis present in the texture. That was again like indicating about the presence of the this new nematic phase in this particular compound. Again, very interesting. I would not go into detail because there's a time limitation here. But at the bottom, you see I have shown a picture there. This is the this is called the freeze fracture TEM. When you have a sample like this, when you do to TEM, this is called the freeze fracture. So by this, we try to measure the heliconical pitch. As I said, that this is a cholesteric nematic but oblique. That means there is a helical structure there. So in that case, when we measured that, it was around coming around 20 nanometers.
Excuse me, sir.
Yes.
Sir, please, really sorry to interrupt you, but we are running out of time.
Sure,
so
sir.
I kindly request you.
Yes.
To sum up your presentation,
Okay,
please.
thank you. Yes, sure, sir. Thank you. So anyway, like you see, this is 20 nanometer helical pitch is there. Then we confirm we can do the X-ray scattering. We did that, and then by that we can also look at the changes, what is happening when you go from nematic to this new nematic phase. And then we plot. This is the important graph which I would like to really present in front of you. All that you can see, this is called the order parameter. When you change the temperature and look at this P2, P4, P6, by this also you can identify and distinguish between these two nematic phases. This is the nematic and the new nematic phase. So you can see that P4 and P6, they are decreasing very sharply in that phase. So that was kind of confirmation by the X-ray scattering. And then when we go for the next compound, it does not have any kind of helical hysteresis that we talk about in the trimer number 1. Same thing happened with the others. And when you look at this X-ray scattering for there, then you can see here at the bottom this figure that when you go to trimer number 2 or trimer number 3, if you do the X-ray scattering, all the P2, P4, P6 were increasing with the decrease in temperature. So there was no hint for the new nematic. It was totally having only the nematic phase. So that is the trimer 2, and same thing we can see with the trimer 3 as also. Now in the nutshell, what was the point I would like to make here at the last, as you can see, that our X-ray scattering that we perform along with the optical plasma microscope observation, what we found that the trimer 1, which was a symmetrical hybrid rod bent core mesogens, confirmed that it has both nematic, high temperature nematic phase, low temperature, basically it's a new nematic phase. However, at the same time, when we went on for trimer 2 and trimer 3, we do not see the new nematic phase at all. So it suggests that means see simply changing only one group at the core of the core benzene ring changes everything. So this shows that this new nematic phase is really the structural dependent, the shape dependent phase is there. So with that, I would give references, and with that, I would like to thank you for your kind attention. So thank you, Kapsa sir.
Thank you very much, sir.
If there is any question, please.
For a very nice presentation. So now the topic is open for discussion. Any question? Okay, I think there is no question. Thank you very much, sir.
Thank you, Kapsa sir.
Now I would like to request the next participant to come forward and tell your OP paper number, please. Next participant who would like to present. Yes, I would like to request the next presenting author to come forward.
Good afternoon, sir.
Yes.
My name Sachin Rai, sir.
Sachin Rai.
जी sir.
Okay. OP paper number, sir?
Sir, 12, sir.
12.
जी sir.
So I request to make Sachin Rai
जी sir.
as a co-host, please.
जी sir. Sir, please allow me.
Yes.
जी.
So I have already requested all the presenting authors to rename your name as a paper number. Mention the paper number instead of your name, so that our support team will easily search. Yes, Sachin Rai,
जी सर
you have been, now you are co-host. You
जी
may
सर
start your presentation.
जी गुड आफ्टरनून सर माई सेल्फ सचिन राय I am a research scholar of Veer Bahadur Singh Purvanchal University Jaunpur. I am presenting a paper of mechanical and thermophysical properties of complex hydrides. My outline of paper: introduction, computational methods, second order elastic constant and third order elastic constant, ultrasonic velocity, Debye average velocity, result and conclusion. The main introduction of complex hydride. The tertiary complex transition hydrides have been considered to be very attractive candidates and have received significant attention as hydrogen storage materials. These compounds show a higher capacity for hydrogen storage in volume density than compressed gaseous and liquid hydrogens. In present work, we have worked to make the relationship between thermophysical and microstructural properties of hexagonal complex hydrides. Complex hydrides will help in the understanding the mechanical behavior of complex hydrides, and it will play an important role in the diagram of industrial equipment with useful physical properties under moderate operation condition. For we have considered elastic constant, stiffness constant, thermal relaxation time, and ultrasonic velocity, and for complex hydrides. Young modulus, bulk modulus, and shear modulus, Pugs ratio, Poisson ratio have also evaluated and discussed for these complex hydride. Elastic constant for hexagonal structures compounds, lattice parameter is 4.46917 and 4.816 and 4.850 angstrom. Complex hydride means Mg3 MnS7 and Mg3 TCS7 and Mg3 Re. Orientation depends ultrasonic velocity, and orientation depends Debye average velocity and thermal relaxation time. The present studies focus on the characterization of complex hydride compound using ultrasonic method, which is non-descriptive in nature. These formulas of temperature dependent second order and third order elastic constant for hexagonal structure materials. These Debye average velocity Vd along the z-axis for this formula hexagonal structures. We have calculated the first order elastic constant and second order of elastic constant. Hexagonal materials, complex hydrides compounds are in a good agreement with the experimental value that, and we are calculating the bulk modulus, shear modulus, and Young modulus, Poisson ratio, Pugs ratio for the complex hydrides. We have draw the graph of angle with ultrasonic velocity VL, VS1 and VS2. Figure 1 and 3, the velocity VL and VS2 of these hydrides have decreases with unique axis of the crystal, and figure 2 and 4, it is evident that the velocity VS2 and V1 at the percent degree and 35 respectively with the z-axis. Anomalous behavior of angle dependent velocity correlated to behavior of second order elastic constant. However, nature angle dependent velocity curves in present work is the nature of angle dependent velocity curve. The figure 5 shows that the thermal relaxation time tau decreases lightly with angle up to percent degree with z-axis and then decreases. The crystal, the time for the of the equilibrium, the thermal phonon distribution decreases with the angle and has maximum percent degree. The principle are simple interaction potential model remains valid, calculating the high order elastic constant for hexagonal structure complex hydrides at room temperature. Mg3ReS7 shows better mechanical property that Mn S7 to larger value of stiffness and elastic constant. Higher order elastic constant and density for these tertiary complex hydrides, mainly the affecting factor of anomalous behavior of ultrasonic velocity. The complex hydrides, the thermal relaxation time is found to the order of picosecond, which defend their hexagonal structure, and tau smallest value theta equal to +1 degree, the time for establishment of equilibrium distribution of phonon. Study can be beneficial for the processing and non-destructive characterization tertiary complex hydrides. These results will provide a ground for investigation measure thermophysical properties in the field of other tertiary complex hydrides. Thank you, sir.
Any question, please? I request the participants. No. Thank you for nice presentation.
Thank you, sir.
Now I would like to request the next presenting author. Next presenting author. M.H. Joshi.
I am Joshi. Paper number 9.
Yes, please make M.H. Joshi as a co-host.
Hi, M.H. Joshi.
M.H. Joshi. Your paper number, sir?
9. Paper number 9.
Then what you are going to present? Hello?
Hello, sir.
Yes, have you taken the permission from the organizer regarding this? Mr. Pawar, Dr. Pawar, please.
Sir, yes, sir.
Sir.
Yeah, yes, sir. Yes, sir.
Yeah, please continue,
Yes,
sir. Please. Yes, M.H. Joshi, sir, please.
Sir. Sir. Okay. Good afternoon to all of you, all the respected members of conference. I am Mukund Joshi, a research student of NSB College Nanded, working under the guidance of Dr. M.R. Deshpande. My outline of the talk is Introduction to Porous Materials, Classification of Porous Materials, Synthesis Mechanism of Microporous Materials and its applications. We know that all the industries throughout the world produces harmful dissipates like agriculture, biological and industrial, etc. These harmful dissipates create a major challenges of serious health risks and environmental risks also. Some of its constituents like arsenic, cadmium, nickel, chromium, etc. may cause cancer, and chemicals like hydrogen fluoride, sulfuric acid, etc. have difficulties in handling plant corrosion and environmental safety disorders. Coal-fired thermal power plants account for 54.3% of the total electricity generation and will remain the mainstay in future. In electric power generation, combustion of coal, the non-volatile fine powder residue of coal forms a fly ash. This fly ash is generated from thermal power stations like Paradi, Vaijanad and Chandrapur, and it creates serious ecological problems. Shockingly, about 90 million tons of fly ash is produced annually in India. More than 70,000 hectares of land is occupied by ash ponds. Major topic is related to porous materials. Therefore, porous material is nothing but a continuous and solid network material filled through voids. A material can be recognized as porous if its internal voids can be filled with gases. The porous materials are classified depending on their pore size into 3 groups: One is microporous, whose pore size is less than 2 nanometer. Mesoporous materials, whose pore size is between 2 to 50 nanometers. And macroporous materials, whose pore size is greater than 50 nanometers. Meso means in between micro and macro. Mesoporous materials may be ordered or disordered. They have surface area 400 to 1000 meters square per gram. They have large pore volume and they have high stability from 500 to 600 degrees Celsius. They are usually synthesized by the use of soft template method. The examples of mesoporous materials are, well-known examples are these, MCM41, SBA15, etc. Microporous materials have inadequate thermal stability and limited catalytic activity because of the electrical neutrality of the framework. Due to the size constraints, they are not suitable for catalytic transformations involving organic molecules having kinetic diameters above 0.75 nanometer. Hence, there has been an ever-growing curiosity in escalating the pore size from micro to mesoporous materials. These are some of the mesoporous materials. The mesoporous materials have characteristics better than the microporous materials. They have better thermal stability, large surface area, and narrow pore size distribution. It has high potential use as an adsorbent or as active catalyst useful in the synthesis of the chemicals. This is the mechanism of formation of mesoporous materials. The chemical applications of the mesoporous materials is as a catalyst and second as a catalyst support. Other applications of MCM41, that is mesoporous materials, are in wastewater treatment, in ion conducting and dielectric materials, and catalytic applications as acid catalysis and basic catalysis. The coal fly ash is of two types, that is class C, which has a capacity to self-cementing, and other is of F type. These coal fly ashes are of slurry of three types: slurry ash, bottom ash, and fly ash. This fly ash is collected from Chandrapur and Parali thermal power station. The reason for choosing these sources of our further investigations are they add value, reduce the cost, and its effective utilization to protect the environment. That is, my research is related to green project. Their potential application in synthesis of highly useful core materials. Their potential application in water purification technology as industrial catalysis, etc. It was desirable to extract silica from coal and rice husk ash and used as a starting material for the synthesis of MCM41. They was optimized by employing different synthesis parameters such as synthesis temperature, calcination temperature, pH of gel, calcination type, and concentration of sodium hydroxide. This is the comparison between CFA, coal fly ash collected from Parali, Vaidyanath, and Chandrapur thermal power station. This is the chemical composition, comparison of chemical compositions from Parali and Chandrapur thermal power station fly ash. Now, the basic, I am going to direct produce the synthesis of mesoporous MCM41. This is the actual, this flowchart actual denotes the practical working in the laboratory of formation of synthesis of MCM41. This MCM41 is synthesized using the hydrothermal method. This is the instrument used for the synthesis of MCM41. The effect of different factors such as influence of synthesis temperature, calcination temperature, pH of gel, calcination period, and CFA NH ratio on the synthesis of CFA MCM41 has been examined. Its XRD studies basic.
Excuse me, Joshi sir. You have 1 minute only to sum up your presentation.
I'm going to all the characterization, that is XRD, same, TAME, TGA, DTG, FTR, etc. are taken And all the characterization techniques reveals that well-ordered mesoporous materials of uniform hexagonal array can be synthesized very conveniently in a very short span of time from an industrial waste, coal fly ash, and agriculture waste rice husk ash. Even after their post-modification, no marginal changes were found in their structural morphology. Hence, these modified forms may be used in basic or acidic catalytic reaction. Sir, this is the one part I am presenting here. Other part I am
Sir, actually, we are running. Actually, I said due to the time constraints, we have to stop you.
Sir.
And because sufficient time should be given to other participants also. So, in order to do this, I request you to stop your presentation. Now, I request the delegates or conference participants to have an interaction with the speaker, Mr. Joshi, sir. If you have any kind of query. I think there is no question from the participants. So I would like to ask next presenting author to come forward and tell his paper number. Next presenting author, please.
I request you to, sir. Dr. Kapse, sir.
Yes, Bijwe, sir.
Sir, please call serial number OP12 P25.
No, actually, we are asking the participants who is interested to present his paper. He may directly come forward.
Okay.
We are allowing him that he may directly come forward.
Okay, sir.
Any of the presenting author whose paper number is from OP1 to OP26, he can come forward and start his presentation. So I request the participant to come forward who is interested to present his research work or her research work. OP1, OP2, rather counting the numbers on behalf of organizing team, I would like to request the presenting author to come forward. I think Pawar sir, now no one is there to present the research work. Hello, Dr. Yanar Pawar sir.
Yes, sir. You may conclude, sir.
Okay.
Yes.
So,
yes, sir.
At the outset of this technical session, I would like to congratulate all the paper presenting authors, P. Singh, P. Patil, then G. Singh, Yes Roy, and M.H. Joshi sir. So everyone has nicely presented their research work, and
Yes, yes,
definitely,
right.
Yes sir. So I congratulate them and thanks for making this event, or you can say the technical session, graceful. With this small note, I would like to conclude this session. Now I hand over this session to Dr. Bijwe sir.
Okay, thank you, sir. Thank you for doing a very nice job for our chairpersons. This is the last part of this technical session too. That is the vote of thanks. Now, I am very thankful to Dr. V.D. Kapse sir for chairing the second technical session of e-conference Raman 2021. His guidance to the students and coordinations with us certainly benefited in the e-conferences. There are total 5 number of students will be present his research work. We have presented their oral presentation. Almost all participants presented their whole presentation very good way. I appreciate their efforts and selection of the topics. I thank everyone who has assisted and coordinated in this technical session. And lastly, I would like to thank to convener of this International Conference Summon 2021, Dr. N.R. Pawar sir, and all the organizing committee for giving me chance to conduct the second technical session. Thanks, and I declare at the end that this session is over. Oh, thank you. Pawar sir. Pawar sir. This technical session will be end now. Hello.
Yes, sir.
This technical session will be end.
Okay. So, on behalf of organizing team, I declare that this technical session is over. Pawar sir.
Thank you, sir. Thank you, sir, for your kind attention.
वहाँ कितने हुए प्रेजेंटेशन?
Sir, either be 5 way, sir. 5 plus 5, that is 10. Hello? Yadva, sir?
Yes, sir. Thank you so much, sir. Thank you so much. Okay.
Yes, sir. Chalo, thank you, sir. Thank you.
Okay, thank you so much.
Thank you, Pawar sir. Bye.
Thank you, sir. Thank you, sir.
Okay, Dr. Bajpayee, see you again tomorrow.
Yes, sir. No doubt.
Okay, bye.
We will
Okay,
be at
Dr. Vijay,
9:30
sir, bye.
tomorrow, no doubt.
I think there is
Okay,
Dr.
sir. Okay,
Devade
sir.
ma'am also.
Thank you, sir.
Okay.
Bye, sir. Good day, sir.
We will be, yes, there at 9:30, no doubt.
Okay, bye.
Okay, thank you, sir. Thank you for
See
your...
you all. Sir.
Yes,
Okay,
right.
thanks to all. Thank you, sir. Thank you, Pawar sir.
Okay, Pawar sir. Thank you so much.
Big congratulations, Pawar sir.
Thank you, sir.
Okay.
Wish you the same, sir.
Congrats, Pawar
Okay,
sir.
thank you, sir.
Thank you.
Congrats, Pawar sir.
Yes, sir. Thank you, sir. Wish you the same, sir. You are the
Thank you,
part
sir.
of
Thank you.
Raman 2021, sir.
Congratulations, Pawar sir.
Thank you, madam. Thank you. आणि तुमचं पण